Science and Engineering Department in this institute. He has done BE in Computer Engineering from Karnataka University, Dharawal, and ME in Computer Science and Engineering from Punjab University, Chandigarh. His specializations are computer networks, image processing, virtual learning, open source technology. He has more than 15 years of teaching and research experience and also possesses 2 years industry experience. He has presented papers in various national, international conferences and is also coordinating MTech course classes here and the short-term courses in the various areas of his specialization also. So as we started yesterday with the introduction of R, he will continue with with R only. He will be interacting with you about the basic components of R. So I over to Mr. Amit Jogar.
Thank you. Good morning, participants. So today's agenda will be on this R will be, just I will mention here also. I hope this is visible to all participants. So agenda of today on R internals will be first we'll see about the capability of R, what R can do and what are the different packages are there. Then we will see about some resources online and offline. Then already we did the installation part. Just I will again revise how to do the installation of this R, and we'll see about the internal of R console. Then we will see about the R commander, how to install the R commander, how to use the R commander. Then we will see about some important commands and syntax. And we'll see how to install the packages and how to load into the library. And finally, we'll see about the workspace of R, how to work with a workspace in R, how to save your work, and how to take the help of any function, any package, or any code or any script. I'm saving this as a R instructions. So side by side, I will tell you also about the presentation and practical demo too. Is it visible to every participant in the remote center? Or shall I increase the visibility? Is it visible? Okay. So we can see this R has a lot of capability through which we can do a lot of work related to search, related to statistics, data analytics, image processing, and a lot of fields are there in which we can use this R, which is available in open source domain, and a lot of packages are available. So R can produce the widest possibilities for graph, charts, result analysis, and we can see a lot of resources are available. So here you can see very useful. There are ample resources, but these are the top 10 resources which one can use. So here you can see one can go to these blogs, rproject.org. I will show you one or two of these blogs and nebel.com. If you require any help, or so there is a stackoverflow.com. If you are working with the advanced statistics, you can go for R statistics. Many persons are contributing here, rbloggers.com, and officially supported by CRAN project.org. Just I will show you these. So now I am opening the browser where I will show you n number of resources and help is available. I opened here r-project.org. I opened here nebel.com. stackoverflow.com. And just note down one website which is available to download more than 3 lakh softwares, not only on R, but also for, like, instead of SPSS, you can use PSPP, or instead of some CAD, you can use FreeCAD, instead of MATLAB, you can use Scilab, and many more. So in this, not sf.com, but it is sf.net, sf.net. More than 3 lakh softwares are available. Even you can download this from official website or you can download from sf.net. In the previous session, we have seen how to do the installation. So you can just go to the R official website, or you can go to this sf.net and you can download this R package. So you can see in multiple windows, I have opened almost all these blogs. And finally, cran.r hyphen product. So at your end, there are heterogeneous researchers who might be doing research in different fields. So you can see this R project for statistical computing, and here you can see the books, documentation is available, manuals are available, a lot of information is available. So if some of you are working with data visualization, or with some economics, or with some other different fields, so you can explore this. So statistical data using R, lot of resources are available. So this is a very good website, r-project.org. So you can see ample number of research papers and informations are available. Some people might be working with biostatistics, or in modeling, or in maybe social science research, or computer simulation, or maybe in biological aspects. So all information is available here. Now I'm closing this. Now another nebel.org or com. Next is what the Stack Overflow. Whenever you feel any kind of problem, you can post your question query here, and you will find lot of experts or other researchers. They will reply your query. So you can see lot of queries and answers are there. Stack Overflow, not only of R but of any related field, technical fields. Then this is the rstatistics.com, where you can see again the codes are given here, and how to install the packages are given here, and how to create interactive cluster head maps, and very good more tutorials are given here. How to do the plotting using ggplot, open source. So you can see lot of articles, lot of posts are given here. A lot of articles are given here. So again, one can explore all these articles in different fields. So analyze your data on cloud, tailor your tables, top 100 packages of the year, k-mean clustering. Everything is mentioned here. So they have mentioned about, if you see collectively of various, there are more than 18,000 packages are there. So approximately more than 10,000 packages are on the comprehensive archive. So you can see these tools, classes and methods for spatial data, G data, and many more. Now we'll start exploring one by one. So this is another R blogger introduction to Bayesian data analysis. How to do the machine learning regression tree and model trees. Then plotting in Python and R. Some applications. Know your data structures. R inside. Step-by-step instructions. You can create your own package also. And many more. So you can see in open domain, in public domain, lot of resources are available. And if you go to this website, sf.net, where you will find around more than 3 lakh softwares. This is the biggest repository in the world, sf.net, or another name is SourceForge. So you can see their left side categories are given here, like science and engineering, graphics, security. So if you click on the science and engineering, so you either, if you know the name, you can put the name here, or you can explore by these menus. So here again you can see OpenCV, programming with data mining with Vika, numerical Python, Octave is there, GNUplot is there, WinPython, and many more. FreeCAD is available, Maxima, Matplot, which we can use day to day in our engineering applications. So related to R, you just type here R, and you will find the link here. So this is a single platform where you will find all the softwares. So again, you can see R packages, R portable, all information you will get here. R packages maintained by another community, YJLEE, R packages, and many more. Now we'll start exploring the internals of R. So now let me show you some packages. So if you go to this cran.r project, you can download also from here R for your platform. Your platform could be Windows operating system, Mac, or Linux. And on the left side, you can see R source is available, packages are available, manuals are available. So if you see the manuals and packages, so these are the manuals are available. introduction to R, how to import, export the data, how to write the R extensions, how to make the interface with other languages like Fortran, C, C++, R internals. So R internals are given there in HTML, PDF, EPUB formats. Reference index is given also mentioned there, where you can refer. So you can see this reference is very important when you're doing something problem with your particular problem. Now, some of you might be working with the any kind of problem that might be related to your classification, clustering, image operation, machine learning, data mining, segmentation, Gaussian mixture matching, or some statistics, or maybe 50-50 MANOVA, ANOVA. So we'll see one by one, or main packages. So you can see this R language and environmental for statistics. And this file, PDF file, is around 3,571 pages are there, which is available for everyone. So this is a reference index alphabetically, like they have mentioned about arithmetic operations, arrays, and alphabetic order, encoding, decoding, integer, full. You can see the complete index or manual is available. Compiler package, dataset packages are given there. Then again in there you can see the device packages are given here. Graphics packages are given, mentioned here. Methods packages are mentioned here, and many more. So all these things can be self-exploratory. So that means anyone can explore himself. Now come to the main packages of this R. So these packages are given either by the date of publication, or by name, in sorting order. So if you click on this, you will find a lot of packages are available alphabetically A to Z. Now, for example, if you are looking for classification, so you just search here with the help of Control F and you type classification. So you can see classification theory for cognitive diagnosis. You can search, either go to the menu and search, or you can press Alt F and you search for your packages. So you will find association classification. This package is available based on association rule, or corrected Bayesian classification is available. Top scoring Bayer paste is available. Data processing binning is available. Classification and regression, feature selections with validation procedures for biomedical, and many more. So if some of you might be working with segmentation or clustering, you can find, just type here clustering. So today we will explore one or two packages. So here you can see clustering and theory applications. Then you can find cross entropy clustering, optimal fast entropy clustering, and many more. Some of you might be interested in image processing. So just type image. So this is a package for image analysis for medical images like MRI. This is the one package. If you click here, this is another package, this is another package, and in this way DICOM formats are there, discontinuities, satellite image, time series analysis are there, and many more. Edge detection and clustering in images. Then some of you might be interested in machine learning or soft computing. So one can type machine learning. So here you can see this is an extreme learning machine algorithm for single hidden layer feedback neural networks. So once you understand how to deal with one package, you can deal with the same with all packages. You can install, same procedure is mentioned there. There is another rapid implementation of machine learning algorithm for genomic data, Espresso. Then factorization machines are available. Machine learning, fuzzy genetic learning algorithm is available. And learning optimization and machine learning for statistics. So this is a package you can see on this side. And then if you see about the, if you are working with the other models, some particular model, so you just type models. So you will find Gaussian mixture matching model or Bayesian model or many more. If you are looking for ANOVA or advanced version of this ANOVA, so you will find design and ANOVA experiments and many more. So what we can conclude, for most of the problems, many packages are available. Now we'll start working with how to do. We have seen so far what R can do for us. Lot of packages are available. Lot of R resources are available. Now we start doing working. So first thing is about the installation. So installation is very easy. You just go to the sf.net or this official website of this RCRAN, comprehensive resources of R. Or go to this project. Then download this R. You will find the exe, then double click and proceed further and you will be able to install. So already in the previous session we have installed this R. Now we'll see how to start working with this R. So this is in this presentation also you can refer installing R. You go to this website, then you will download. It will ask for the language, in which language you want to install. Then you have to follow the agreement of the end user license agreement. Then you have to specify the path where you want to install. Then you want to install 32-bit file or 64 or both. And then finally it will specify for the startup menu, and in this way R will be ready. Now we'll see about the R console. Now I am opening this R. I hope this is visible to all remote centers. I will try to increase the font size. Under this preferences, there is a console row and column, page row, graphics. Somewhere will be font size. So here font size, instead of 10, I am writing here 16. I hope now this is a bit better. Now what all you can do a number of things in this. First of all, we should know what all the packages are available with us. Out of thousands of packages, few packages will be there. When you install R, few packages will be there. So how to find that? This is the command, library. So when you run this library, that means these packages are available. Mass, matrix, NM, and few more packages are available. These packages are available. Around 10-15 packages are available. When we install other packages, you will see when we run library command, we will be able to see more. And it is also showing what this package do. For example, matrix. So what it do? It deals with the sparse and dense metric classes and methods. Similarly with the neural networks, and these are the few packages are there. So with the help of library command, we can see about the packages. Now let me run few things for you. So like yesterday we have seen about, if you write here 2 + 5 or multiply by this, you get the answer directly. If you don't specify the variable, you will find the immediately on the answer. Now let's say you have some number 44 and you have some number 55 and you want to do multiplication of this A into B. Now you want to print the result. So you can write here either print or you can print cat C. So your value is stored in C variable. So you can see the answer in this way. Sometimes you want to find the exponential. So you can use exponential. Let's say exponential of -2. And it is a case sensitive. If I write here exp same thing, so this is it will not be understood because it's a case sensitive. Just like in Linux, all commands are case sensitive. So similarly, this is case sensitive. Sometime in your scientific application, or you have to require the log. So simply we can use the function log, and we can specify the base. So in this case, I'm using base 10. So you will find the log of 100 is 2. Now we will start working with some basic statistics, and then we'll see about the advanced version of statistics with the help of GUI. All of you will be able to run any statistics function, parametric test, non-parametric test, t-test, ANOVA test, etc., etc., without any programming. Before that, just we'll see with the few commands, and then we will explore with the GUI tool. So let's say I'm running here. I want some seed value, some random value. So there is a function runif, and if you need to help any of the function, you can use a help runif. When you run this help runif, it will open the browser or this HTTPD's help server, and you will find all the help will be available on that. So in this way, you will be able to find help on any topic. So I'm closing other unnecessarily other tabs. So now if I want to generate, let's say 10 random number. So what we can specify, same function. We can run the same function. So I am now going to use runif. Let's say I want to generate 5 random number. I have generated 5 random number. So these random numbers are always in between 0 and 1. But sometime for our experiment, for our simulation, we required some, let's say 100 number, 500 number in particular range. So for example, I need the whenever you will run this, I am running again this random number. So again it will generate random number. Again when I run, it will generate random number. So that means there is in the program, it's a randomness is there. So you will get again either on the same system or in different system, different answers. Randomness. Now we want to generate these random numbers are always in between 0 and 1 by default. Now for our experiment, we required random number in between, let's say 50 and 100. So, and we required, let's say 10 random numbers. So what we required, 10 random numbers in between 50 and 100. So how we can achieve that? So we'll say run if, how many numbers we require? 10. And in between, so we can give minimum is equal to 50 and max is equal to 100. So in that way, now you can see we get 10 random number in between 50 and 100. If you want the random number in between 5 and 10, so what you can do, 5 and you can specify the range also. If you don't specify the range, you will get the 10 random numbers in between 0 and 1. So I'm showing you, if you don't specify the range, you will get the 10 random number in between 0 and 1. Now we'll start some basic statistics, and then we'll find the this thing. Now, in most of our experiment, we required to find the correlation. What is the correlation between our input experiment and output experiment? Sometimes we want to find the sum. Sometimes we want to find the standard deviation, mean, minimum, maximum sum. So let's say, just to show you about minimum, maximum, let's say we have generated random number. Let's say I'm generating 20 random numbers or 20 random numbers in between 1 and 20. So minimum will be 1, maximum is equal to 20. So I got 20 random numbers. I want to find a minimum number, which is a minimum number, because if you see series, so it's starting from 14 dot something, 13, 12, 11, 16, randomly, 5, 1 something. So easily we can use a function min. And one more thing, we can store this result in some variable. So this is my output. I'm showing you again what I did. I run this program. I generated 20 numbers in between 1 and 20. And these are my 20 numbers, random numbers in between 1 and 20. I want to find the minimum of this. So simple, I will say minimum of n. So minimum of n is coming 4 point something. And if I want to find the maximum, I can say maximum. All maximum easily. I want to sum all these numbers. So we can do sum. So sum is 204. So 20 random numbers which was generated in between 1 and 20, we get sum of those numbers 204. Now we want to find the mean. How to find the mean? Any participant? Very good. So we add all the numbers and divide by the total number. So total number is 20. Summation of also it will be 204 divided by 20. So it will be approximately around 10 point something. To find the mean function is there. So we get 10.23 mean. Now I want to find the standard deviation. So what is the formula for standard deviation? Very good. So we can give SD. So we get the standard deviation 4.34. Now let me show you some correlation and some mean square error. So let's say we have the input and output. Any question, query from any participant? Okay. So we have seen the basics of some statistics. Now let's say this is my input. I have generated input as 100 numbers in between 1 and 5. Max is equal to 5. Okay. Now if I want to see it, I will just put the, so these are my one kind of input. I'm doing some experiment on data, big data, or some kind of a problem, or maybe some weather, or whatever problem is there. Now I got these values, or maybe some feature extraction. Using some feature extraction, we got this. Many people who are working with the network security, there are certain open source tools through which they can collect the real-time data, and in this way, or image processing, or data mining, or cloud computing, somehow they got this kind of data. Now, if you want to see the first few lines, so there is a head and tail is available, just like in Linux command. In Linux, head do the first 10 lines, and tail do the last 10 lines. In this, it will do the first 6 lines. And if we run the tail input, it will show the last 6 values. We will see last 6 values, 1, 2, 3, 4, and 5, 6. And if you want to specify few particular line, that is also possible by specifying the parameter. Now, so this was my input. Now I did some experiments, some modeling, and I got some output. So let's say output is in this way. minimum is equal to this, maximum is equal to 5. So because of the randomness, I will get the different output. So this is my result. So I got two vectors. We got two vectors, and this is my input and this is my output. Now on this, we want to find the mean square error, the deviation or correlation, or we want to find the sum. So first we'll see the difference. So difference will be my input and my output. We will find the difference. So if you see, so this is my difference. And if you want to find the sum of this input and output, we can find the sum of input minus output. The sum is this. Why we are doing sum? Because we have to find the mean error. How to find the mean error? Mean square error or mean error. So we can find the mean, and also known as root mean square error, absolute of input minus output. And one more bracket is missing for the mean function. So mean error is equal to mean and absolute of input minus output, this one. Now if we see the mean error, this is our mean error. And if we want to find the correlation, so correlation may be either 0 or it will be in between -1 to 1. So through correlation we can find out, so we can find input dot out comma output. So correlation is coming minus the minus 0. What does it mean? So data is not correlated. How we can see this was our input and this is our output. So you can see lot of variation is there. There is no correlation. Now I got this result and I want to store this result in some file. So today we'll see how to export our result in some file and how to read any file. So those files could be of any format. Excel, if it's Excel, XLS format will be there. If it's from some other database, XML format could be there. If it's from some other format, we can convert into CSV format. Or if it's online data, if you're doing some online prediction of social behavior, online behavior on social media, like on Facebook or maybe on Twitter, so those formats are available in JSON format. And if you're doing some medical research on diabetes or cancer patients or data, so data sets are available which are in ARFF format, attribute relation file formats. And all these formats can be combined with this R tool. So now we'll see about how to write this data to our data. Now we will see where we are. There is a command pwd, present working directory, or we can see current working directory. Name was anyhow. Now I am going to save my result in data in some file. So I can write.csv, and I will use this data frame, data.frame. So what was my data? Input, output, and the file name. We can give our file name. Let's say NITTTR sample data. Any name you can give, and you can give CSV because we are using write.csv. And we can give row names. We shall want to, now this data was not having any headers. That means attributes were not there. Like whenever we have data of any student, we have the roll number, name, age, and other attributes are there, email address, marks are there. But in this, we have the data without header. So we can say row names is equal to false. And now to get the present directory, the name is get. Now we'll see. So can you notice what type of error is there? Typing mistake. The file, the variable which was holding the result was input and output, whereas in this line we have given output, spelling mistake. So whenever there is an error, automatically this will take care. So the name was input and output. So by mistake we put output, spelling mistake. So now this has been saved. Which file? NitterSampleData.csv, which was not available earlier. It has write our data in this file. Now to get the data, we should know where we are. So we can use pwd or getwd. So getwd will give us the working directory. So this data has been saved in which path? C user ETV and documents. So we can see from here, go to my computer. Then we go to the users. C. Then you can go to the users. Then you will go to the ETV. And after ETV, the name was documents. So here, can you see this file, Nitter sample data? So if we open this Nitter sample data, we will get the data in this way. So input, output. So these were the two variables, and this is our 100 values. Why it's showing 101? Because one row has been taken by this input and output. Got it? I am repeating again. Let's say we want to generate two series. Series 1 is equal to 1:100 and series 2 is a number from, let's say, in reverse order, or maybe from 200 to 300. So it is possible to say multiple values to one variable. So this is our series 1 and this is our series 2. So series 1 has a number from 1 to 100, series 2 has a number from 200 to 300. We want to store this data in a file. So how we can save? So we can give write.csv, comma separable value file, data.frame, and here we can pass these values, series 1, comma series 2. If you are dealing with the multiple, you can give the multiple values also. Series 1, series 2, series 3, series 4. And file name, let's say NITTR series.csv. And let's say this time we have not given row.names is equal to false. So now if you analyze, so write.csv, then data.frame, series 1, comma series 2, spelling is okay. The file name is are going to print different number of rows. So knitted.csv. Okay, the row names should be row dot names is equal to false. Now the problem is coming with the data frame. Why? If you see again, we have series 1, 1 to 100. Okay, and series 1 is again, let's say I have same data and no more change in the code. So when we were typing from 1 to 100, it was giving 100 values. And when we were typing from 200 to 300, it was giving 101 values. So that was a mismatch. So value should be same. Now if we see again this knitter series.csv in the same folder, see users, and how to find the path, again give the command this get working directory, get working directory, see users etv documents, see users etv documents. So it's giving knitter series. So you can see now series 1, series 2, and these 100 values. If you want, again, I'm repeating again. So no need to type code again. Now series 1 is 1 to 100. So in series 2, we can give 201 to 300. Instead of 200, it should be 300. And then again, put the same code. And in this, now this time we'll say new knitter series, new, and same code. So this time no problem came. And as I mentioned you, this is optional. So if we don't give the this thing new, and now let's say we have given the name new knitter series 1, and if we see again get wd, where it has been saved, it is saved in the documents. So we can go to the documents, and here we find this new knitter series 1. So series 1, that was the previous value, and series 2 in this way, starting from to this one. So I hope it is understood. So we can write the same thing with the row name false, and we can find out again. Documents, knitter series, and new knitter series 1 and 2. So we have seen about generating the random number, read the numbers. Now we'll see about the advanced statistics. So for that, we'll see how to install the package. So now next we'll see about the package name. So there are two ways to install the package. This is the one name, install.packages. And if we don't know the name, we can write in this way. It will open a list of the packages, all packages. So for that, your system must be connected to the internet. It will go to the repository and it will connect with that. So here you can see it will ask for the repository from where you want to install. So you can select any of the repository. So any nearest country, or France, Denmark, or anything. Once you connect it to that server, it will show the list of the packages available. So now these are the packages. The same packages which we have seen at the CRAN website, those thousands of packages. So this is the one way. If you don't know the name, you can take the help from here. Now we are going to install R Commander. Now what we are going to do, so I am cancelling this and I will show the other way. This is a one way, another way. So we have seen about the capabilities, packages, R resources, how to install, and R console, and how to work with this. Now next is about the R Commander, and then we'll see more about the packages and workspace. So R Commander is a package, the same package with what you have seen. So we can say install dot packages, and we can specify here R Commander. Now deliberately I am writing this R Commander in lowercase just to show you this is also again a case sensitive. So when you write here in R Commander in this way, it will go to the repository and will find out whether this package is available or not. So what it's showing, this package is not available, R Commander, because this package is a case sensitive. So R should be capital. So it's showing R Commander is not available. So they are recommending you. They are giving you R CMDR. Instead of this, you have to specify R Commander. So this is a one way. In the same way you can do with any package. Install.packages R Commander. So you can see it's installing all the dependencies also. So depend on the speed of the internet and this connectivity, it will take time. It will vary from system to system. So for one package, sometimes it may take 2 to 3 minutes, or maybe less, or maybe more. So any question, query so far from any remote center or from any participant from the NITTTH Chandigarh? So you can see this package is almost installed. So these are the two ways through which you can install any package. After this, we'll see if you don't have internet connection, then also you can install the package. So that also I will show you. So for that, you have to go to the repository, download those packages, and then there is another method through which we can install in offline. So by the time it's installing, I will show you how to do the offline. So install packages. There are two ways, online and offline. In online, you say install packages. This is the one way. It will give the list, or you can give the install dot packages and the package name. Package name. In offline, download the package. Example, like let's say machine learning package is there. Here you can perform lot of RETL. So if you want to install RETL or the package which I am using, R Commander, it's a case sensitive. It is R Commander. How you can install? Either you can give install package and this package name, or you go to the same repository. It's still running in the background. So we go to the package. Here packages. On the left side there is a link. Then you can click any of the option. And here, if you want to study or read more on this, R Commander. So alphabetically also you can go directly or search here. So again you will find lot of packages are there. So here you can see RCarto package is there, RCA package is there, relation class analysis. Bootstrapping functions are the computational geometry is available. So here this is R Commander. So you can click here R Commander. You can download this. And if you want to study more on this, this is the reference manuals are also available. And this is a package source. So for window binaries, you have this zip file. You can save directly. And let's say we have created one folder on the desktop. You can download this zip file. And this is the manual of this R Commander. This manual is of 44 pages. So some of the functions we will explore just now. And here description, details, customization, configurations, commands, examples, everything is mentioned here in this. This is a very good tool for performing multiple different kind of statistics like Pearson test, t-test, factors, the arguments you can pass here. So we'll go to the again the package we are interested in, Rattle. I've given here Rattle. So this is a graphical user interface for machine learning and data mining. So you can do installation either that way or you can download from here. So this is the citation information. These are the materials are available. This is a reference manual is available, and you can download the package Windows binary rattle.release zip, and now we have saved this. So again in the background we see it's still the packages are installing. All dependencies packages are going on. So we have downloaded 2 packages. So here we'll copy this R commander. So this is all about the documentation, and this is about the package detail. So again, if you see about what you can do binning, add a boost, random forest, plotting. Some data sets are available. You can do all these detail description. Examples are mentioned here. So now again we'll go back to this. So this has been installed. So again, how to check? So there is a command again, same command, library. In the library now you can see in this library so here you can see R commander has been installed. Now after this, when we install Rattle, so that list will also come here. Now these are the comments. So whenever we install any package, now we have to invoke that package. So we can invoke in this way, library R commander. Now what is the mistake here? As I mentioned you, this is a case sensitive. So R should be capital, library R commander. When we invoke this library R commander, so it's showing some packages are not there because we have not mentioned the dependencies. So whenever you are installing any package, you must mention dependencies is equal to true, and this true should be in capital letter. So again, if something will be missing, it will install the dependencies. So sometimes the problem came with the repositories. So you can change the repository also, or automatically it will take care. Now after installing of this, we'll see how to perform advanced statistics, how to import the files. So I brought one Excel file, just I will show you meanwhile. This is one Excel file of students data. And this Excel file consists of some information about first name, second name, gender, mobile, graduation, post. So statistically we cannot do much on this, but just to show for the demonstration purposes, if you have similar kind of data, what all you can do. So data must be in proper way or proper format. So this is a simple data of students. Just to I will show you how to read this in the R and how to do some kind of different statistics function. So instead of this, I will give students here, students data. The name is students data, and I'm storing in the documents. After processing and after doing this, we'll see in the last how to save the workspace, and then we'll do the revision what we did today. So now it's showing successfully it has taken these dependencies like Xtable, R6, source tools, MVT normal, and some more HTML widgets, etc. So again, after installing this, we have to run the library R commander. When we run this library R commander, it will load that package in the current workspace, and it will open the GUI through which we can do n number of operations. Now you can see. So when we talk on the data set, we can create our own data set or we can import. Let's say we want to create our own data set. So we'll say new data set. And we can give the name, let's say data set 1, any name you can give. So data set consists of row and column. You want to add column, you can add the column, you can add the column, you can put here roll number, you can put the name, etc., etc. This is a one way you can add your own data. Or instead of this, you go to again this R commander, or you go to the data and import data. So you can import data from SPSS, you can import from Excel file, you can import from text file, you can even from some URL, clipboard, SAS, Minitab, or some other packages. Or before this, let me show you some from here you have all the help on this website commander. These are the tools are available, these are the distributions are available. You can have continuous distributions where you can have normal distribution, T distribution, chi-square distribution, F distribution, exponential distribution, uniform, Cauchy distribution, log, logistic, gamma distribution, and many more. And discrete, in discrete you have binomial, Poisson, geometric, negative. Models are available. You can generate graphs, you can have numerical, you can have this. Under graph, you can customize, you can make 3D graph. Under statistics, you can perform correlation matrix, some table of statistics, frequency distribution, correlation test, contingency table, means. Under means, you can perform ANOVA, multi-way ANOVA, one-way ANOVA, proportions, variances, non-parametric test, Kruskal test, Friedman test, dimensional test, cluster analysis. Under cluster analysis, you can perform hierarchical cluster, k-means, you have fit models, etc., etc. So first, you should know how to import the data. So right now, just to show you, I am importing one data from the Excel file that was from the students' data, and we can give here the any name, data set of students, or you can give any name, then say OK, and it will ask you where is the data. So that data, if you remember, I stored in the documents. And what was the file name? Students data. Knitter students data, some name was there. Here you can see students data, Excel file. You can open this file. So when you open, by default in Excel, there are sheets are there, 1, 2, 3. You want to open which sheet? 1, 2, or 3. So let's say I have given here sheet number 1. You want to edit this data, that is also possible. So it's giving some message, warning message, some problem with the Excel file, but anyhow, it has opened string factor. You want to edit, you can click on this edit. You can, once you click this, you can add, remove. So you can see the middle name was missing. So it has shown as a not applicable. NA field, date of birth, and many more fields are available. So some data are there, some data is not there. Now after reading this data, you can add row, add column, etc. You can do the editing also. Discard editing, so I will say yes. So no editing has been done. Now on this data, what you can do, you can perform all these summaries. So this will not be appropriate for this data, just to show you. So you can count frequency distribution. So frequency distribution on which variables? So again on first name and gender I have given. So here you will find how many females, how many males are there in different categories. So you will find the percentage. So this is the output. You want to perform, now we left with 10 minutes. So just I will show you, you want to perform some non-parametric test. So select that test. On which group you want to perform, select that perform group, response, and say OK. This is not valid data, it's showing the same thing, and you have to select data. Okay, so some other things we can try. So you can try with some model, linear regression model. So you have one side response time, and another is what you have done in the other packages, and you will find F statistics. You have got this much value, and P value you got. So if you have proper data, you can do n number of these things. So now we left with last 10 minutes. So I will, before concluding, I will show you another how to do the offline installation of the package and about the workspace. So I'm exiting this. So I'm closing the R commander. Now you can go to the package and there is options are there: load package, install package is online or offline, install package from local file. So you click on that. So if you remember, I have downloaded 2 packages on the desktop in the file. One folder, and here I have downloaded Rattle. Then open. Now what it has shown, package Rattle successfully unpacked and MD5 sum checked. Without taking much time, it has installed in no time. Only problem is that when we run this package, so the issue may come with the dependencies, if it requires some dependencies. So how we now run this? So same procedure, library, and we can say Rattle. So what it's showing, package or namespace load failed to in space because there is no package or the dependencies. This is the issue. So if there are packages and if you have the dependencies, then you can install. Otherwise, in this way you can try. So how we can install in another way? So packages, install packages, then specify here Rattle and say dependencies is equal to true. Then just to show you, if you write in lowercase, it will give the error. So object true not found. So it has to be in uppercase. So it will go to the repository and it will install all these packages, graph, RBGL. In this way we can install any package. Okay, meanwhile it's installing, let me show you one more thing. You can even write your script in this way. You can save test1. You even through command line. You can go to that folder, CD, C users, it will be documents, documents. Here there is a folder. Here you can write R script test1.r. Okay, before that we have to put his name in the environment. Now when we install the R, we want that R script should work just like in Java. We have Java C and Java. So this is installed in C program files. C programs files. Then here we have R 3.0 bin. So simple, we will click here copy this and put as a environment variable. This is very important. So go to the My Computer. Then go to the properties. Then go to the advanced system settings. Go to this environment variables. Then go to this system variable. There is a path. Under the system variable, there is a path. Go to the edit and don't delete this. Just go to the end of this line, put semicolon and paste it. And then say OK. OK. And then exit this once. Then again run this command prompt. Then go to that file, documents, R script, test1.r. This version of R is not compatible with the version of Windows you are running. So there is an issue with the 32-bit and 64-bit. So what I mean to say, if you write the script, you can run your script in this way also, just like you run your Java code. So your system information to see whether you need this bit or 64-bit, that we have to specify. How to check that? We go to the computer again, properties, and here we can see our machine is of 32-bit. So there might be chances that in the previous session it has been installed as a 64-bit. So we have to select for the 32-bit. And in this way we can run R script also. So now we'll see whether that has been installed or still going on. So still it's installing the required packages. It has installed around 70%. Now it has reached around 90%. So here you can see now almost done. And after this, we'll see about the workspace. Another 2 more packages are required, dependencies. These kind of packages you have to do only once. So once this is installed on your machines, then after that you have to program your code and solve your problems. So this is a one-time job. Any other question, query so far from any center or from NIEER participants? So you can see all these things are installing in this folder. See. So what I'm doing, I'm putting the 32-bit environment also under the path. That means if you are installing some packages, you don't have to wait for the packages. You can write your program in the console, and then from here you can run. You have to exit once. Okay, this package is almost installed. Now we'll see how to use this package for data mining and machine learning applications. So again, I'm relaunching this R. And here now you can see with the help of library what all the packages are there. So here you can see we have installed two packages. One was R Commander, RCMDR, and RATTLE. So this is a graphical user interface for data mining in R. And whenever you want to launch any package, so you have to say library RATTLE, or if there is some problem, you have to reinstall it, or you can say R Commander. Once you run this R Commander, it will open that GUI and you can import your data and you can do all those experiments. You can go to the data, you can import your data. After that, you can perform all these statistical experiments. Now, in the last, whatever you have done, let's say we have used two variables. And in these two variables, I am generating 100 random numbers b is equal to run if, or let's say 500 random numbers. So we have run these many numbers. I want to save whatever the work we have done, we want to save. So we can run with the help of, this will increase the font size. This is very, very important. So whatever you do in the last, you have to save your work. So you can see we have done very important experiment with these value. You want to save it. So the command to save is save dot image, and you give the name, file name is equal to let's say today work. You can save in this way, today work. In this way you can save today work, and this has been saved. Now where it has been saved, so with the help of getWD, you can see the path. So by default the path is under ETB document, so it has to be today work. So how to check that? Go to that documents and see whether it has been saved. So you can you see this today work, one file is there, today work. So after, let's say you have saved this work, or you want to save in other folder, so you can specify the name. Let's say here in our computer we have C, E, and F. Even you can save in different drive, mother give the name F colon this. Even you can specify the name today work. Let's say name is, now we have given here 1. And when you have to specify the path, you cannot compress file F. So you have to specify some way. In this way, you can give the name or you can give any name. So let's say we have given the name here, file today work 1. Today work, some name, file we have given, save dot image. And let's say after few days you want to again use this. So when you launch this R, the command is load. Next time when you want to save, go to the preference, increase the font size. So simply you have to say, if you say there is no A, there is no B, because these values were in the workspace. So what was the workspace name? Load, and the workspace name was today work 2, or whatever the name you have given here. Today work 2, and in this way. There were typing mistake. You have to say load to work today work 2. Then if you say A and B, all your variables will come. What we have learned so far here, The two commands are very, very important. Whenever you want, you save the save.image and you specify the file name, where you want to, by which name you want to save your work. You can give. And afterwards, when you want to read that, say load work one. Or even through menus you can do, or in this way you can do. Or they are not saved by this name, so you can say load work one. And when we say load work one, again it has to be in the double quotes. Load work one. So now I'm about to conclude. So what we did today, so we have seen about the capabilities of the R. We have seen thousands of packages. We explored two packages by the name R Commander and RETL. Minor problem came with the RETL, dependencies issue was there. We have seen about the various blogs and resources. We have seen about the installation. We have seen about the R console. Then in the R Commander, that is nothing but this R Commander, RCMDR, where we have import our data and perform the various statistical tests. Some commands and syntax there, where we have seen about the how to generate random values and how to perform minimum, maximum, standard deviation, correlation, and some more experiments we did there. And we have seen about the packages, library, and finally how to see the workspace in R and help. So with this word, I thank one and all. And if you have any question or query later on, you can even email us, amit@nittrtrchd.ac.in. Thank you one and all.
Is any query from any nodal center?
Any question, query from remote center? Okay, if there is no question, query, the next session will be at 7:30. Next session at 11:30.
second session of the day. Uh, Before I request for the second session, let me just share with you. We will be having one task, not in this session. That is your home task. What you have to do in earlier you had two presentations. You have in first presentation you have thought of the some research problem and objectives hypotheses were written for that. In the second in while questionnaire also we have given you selected some problem and you had written questionnaire for that. Now what you are to do, we go for one step further. We have already discussed various statistical techniques, so you are to match for which problem you will suggest which type of statistical technique you are going to use. If those who have not done yet that work, then on fresh you can think of some problem, research problem, and suggest the statistical technique which you are going to use. Say when you are going for a relationship, you go for the correlation type of studies. When your data is in frequencies and you want relationship, you may go for the chi-square. So depending upon your problem, statistical technique used will change. So you are to write the statistical technique why you are using that. So tomorrow in the very first session we will start with the presentations from your side. The scheduled lectures of SPSS throughout, those will be only in the afternoon session, that is from 2 to 4 p.m. we will be having SPSS. In the second lecture we have invited one expert for discussing action research. What type of research you can, as a teacher, you can carry out for improving small problems at your work. So that will be the schedule for tomorrow. And now I welcome Madam Shano Solanki. She is a faculty in Computer Science and Engineering Department. She has done BSc Computer Science from Kurukshetra University and ME Computer Science and Engineering from Thapar University, Patiala. She is also pursuing her PhD. Her specializations are in the field of advanced algorithms, semantic web technologies, machine learning, and data mining. She is also coordinating in our institution long-term as well as short-term problem, and she possesses more than 16 years of teaching and research experience. She will be interacting with you on graphic analysis using R. So, Madam, please.
Thank you, ma'am. So I welcome all the remote center participants in this session on graphical analysis using R language. You have attended earlier R introduction session and how you can go about using the R interface for analyzing your data graphically. So in this session, you will get an idea about what kind of graphical plots you can go ahead with your data. So when we are going to create a graph that is possessing various properties and using R language commands, you can improve the look and feel of your graphical plot. And for that purpose, R language is providing you with a command that is referred as plot command. And using this command, you can draw a particular graph in R and you can modify its properties using the various arguments. So as you can see that in a plot command, we can have various attributes. For example, you can modify the points that you are going to plot, or using the line which you are plotting, you can specify what kind of color you want to display or what kind of line width you want to opt for. Or you can specify the different features of your graph, like modifying the axis of your graph, or modifying the values displayed on that, or making certain changes in the title and the subtitle or the legend information. So these kind of all property changes you can done, but the change in R is that as R is a language, so you will have to do all the tasks using a particular command and by modifying its values. So one by one we will see how to go about. Before we proceed with the plot command, you will have to make use of certain data set. So R provides you with many inbuilt data sets and pressure is one of them. So before you go ahead with any particular graphical analysis, you will have to look for its structure. And in R language, we are having a command str for that purpose. Bottom of the slides, you can have an idea about the commands that you can use. The very first command that is used is attach command. Attach, and within parentheses, the name of the data set. Like in this case, attach within parentheses, I am using pressure. Pressure is the name of the data set. So accordingly, it will allow you to draw your graph only after running this command. So first command that you will have to run in your R interface is to attach with that particular data set. And the second command that I'm using here is str command. So if you are not sure that what kind of variables are there in that data set or what kind of values it possesses, so you can first look into the structure of your data set. For that purpose, str command is being used. Str within brackets, you can specify again the name of the data set. And the third command, as you can see, so I hope now you can understand that this greater than sign is just the prompt in the R interface, after which you can write your R language commands. So the third command in continuity which is needed is plot command. At this instance, I am not using any additional argument, only it is telling that which attributes or which variables are to be used for plotting your graph. So I am opting for temperature versus pressure. You can note down one more command, that is data command. So if you want to look into the values of the different variables like temperature and pressure, so you can pass the command on the R prompt data and within parentheses the name of the data set. So as I said earlier, we are going to make use of pressure data set. So data within brackets, pressure means I can display after this the whole data that it is having. So you will have to pass the two commands in continuity, data within brackets pressure and then simply pressure. So after executing this command in the R console, you can have an idea about that how many observations it is already having, what kind of values it is having, and then you can proceed with the plotting of the graph. So this task is to be done before you plot the things. So you can first look into the structure of that, you can view the data, and then you can view the structure also, and then you can allow the R console to run the command plot, which will help you to draw the graph as per your need. So next thing comes is, can we save our plot also? So there are two methods for that. One is that from the R console, you can easily save your file. Go to the file menu and click on the save as option. As you save any other file on your system, in the similar manner, R console is allowing you to save your plot file using either PDF or .jpeg or any other format that you are interested in. You can opt for PNG file format also, .jpg file format also, .pdf also. So one more interesting thing over here is, can we do the same thing without going to the file menu? So there is the second method to save your plot, which is being written at the end. You can opt for the particular file type that you want to save, like I want to save it using the JPEG. So for that purpose, there is a function in our language. You can just look at the last bullet, which is displayed in this slide. JPEG within brackets, within double quotes, you write down name of the file. Let's say mygraph.jpg. Fine. So you will have to write this command in order to save your plot using the name mygraph.jpg. Similarly, you can save it as mygraph.pdf or mygraph.wmf or mygraph.png. These are the various file formats. Normally, we want to save our graph as an image file so that we can make use of this particular graph in some other report or in some other thesis file as an integrated component. So later on, you can make use of this graphical results. So in this kind of method, you need to run the 3 commands, which is written as method 1. It is the command way to save your file. So you will have to first specify which particular file format you want to choose, and then you plot the graph. Just look at the method 1, line 1, JPEG, mygraph.png or .jpg, whatsoever file format. But you will have to remember that outside also the name should be same. If I'm interested in saving it as .jpg, the name of the function should be JPEG. If it is a PNG file, you will have to change the name of the function PNG within brackets, double quotes में आप बताएंगे उसमें name of the file mygraph.png. Then plot the graph, let's say between temperature and pressure, and then dev.off. I have written dev. Just look at the top. The cursor is not coming. Okay. So as we can see here, this command dev.off. So you will have to execute these 3 commands in sequence in order to save your file. So if you feel comfortable using all these commands, you can do it like this. So by default, it will save it in My Documents folder. Otherwise, you can simply opt for the R console file menu. Second method, that is comparatively easier for the beginners. So simply save your plot by going to file menu and then save as option, as you do it with other kind of file saving. So these are the 2 ways through which we can save the plot. So as I said earlier, in graphical analysis, while drawing any kind of plot, we do have many kind of needs. Let's say I want to emphasize something. I want to make certain changes in the display of the points in my graph, which are being represented either by some points or by a line graph. So these kind of things can be modified using the plot command arguments. So just look over here, what kind of things you can change. Type of a graph, I can modify it. Symbols of points, like in this particular image, you can see that the points are being displayed using circular red color points. Fine. So if you want to display, let's say in place of these red circles, you want to display it using star, or you want to put over here some other kind of symbol, let's say square, or some alphabet you want to display, let's say A or B. So these all kind of changes I can do in my graph. Then comes to size of points. So if you feel that these points which are displayed in the graph are small enough and you want to make bigger, so you can modify that also. You can make changes in the line type. Right now it is a solid filled line in your graph. If you want to show it as dotted line, you want to show it as dashed line, so all these kind of changes I can do. And then further, color of points and lines. You can modify color also. Rather than making use of red, if you don't feel that red is looking good, you can make the changes. So these all kind of color changes or font changes or look and feel of the graph can be modified using the plot command arguments. So in this slide, you can go through what kind of changes I can make in the type argument. So you need not to remember all this. Remember this thing. In R console, you're having help regarding all kind of commands. You just need to put question mark over there, question mark and then plot command. So it will show you all kind of help related to all attributes of plot command. So for your understanding, I have given certain type arguments, like you can put in type equals to P or type equals to L or type equals to B, H, S, N. Need not to cram all this. These are the various possibilities that we can use. So just look at the example given. I am using additional attribute type. It was not there in the earlier case. When I run first time the plot command, it was simply having two variable names, plot, temperature, comma, pressure. But I want to go ahead with certain changes. So I want to specify type equals to P. By default also, the graph is being displayed using points representation. So if you want to make certain changes, you can do. You can see the result of this as in this graph. So if you will run the earlier command, plot, temperature, comma, pressure, comma, type equals to within double quotes P. So P means I want to plot the points. I hope you are getting the difference between the earlier display and this one. It is only having points. There is no connected line in between. So how you will go about that? If you want to display a line also. So for that purpose, you can do type equals to L. L for line. If you are using type equals to P, it will only display points. If you are using type equals to B, B means points as well as line. And if you are using H, it will show you graph with vertical lines. So these are all the different possibilities which can be used using the type argument. So till now we have covered how to plot a simple graph by passing the required variables along the X and Y axis. So you will have to choose as per your requirement from the data set between which two variables you want to display the graph. And then you can use the another argument, that is type. Type equals to P or L or B. So default setting, you can see that type equals to P is default. If you will not give any type argument, it will display using points. It is default setting. Otherwise, you will have to use type equals to certain value. Now come to another kind of arguments that we can choose. Just look at this table at the bottom of this slide. What kind of different possibilities we do have. So you can see that if I will use PCH equals to 0, it will make use of this square symbol for plotting the points in the graph. If I will make use of 1, it will use diamond shape. For 5, if I am using PCH equals to 2, it will show triangle. Instead of using round circles in the plot of a graph, it will use triangle single. Similarly, you have different values. So how many values you can go ahead? PCH equals to 0 to 25. Different kind of symbols you can make use of for plotting your graph. So let's say we want to display star. So star is having a value in the table. PCH equals to 8, right? So you will have to use plot, temperature, comma, pressure, comma, type equals to, if you want to give some type, and then comma, PCH equals to 8. So here the command also is given in the particular pic. Plot, temperature, comma, pressure. Like type equals to B means it will use points also and line also for the display. As you can see in the graph also, it is showing you line connecting the different points in the graph plus the symbol that you are specifying. PCH equals to 11 means this a star symbol is there. So in this manner, I can modify my graph using these attributes. So one by one, you will see that there are lot many other options also that you can use. Then comes the next attribute in our collection of plot command arguments, that is font. Font is only used when we are using some character symbol. If we are using some character symbols, please note down, this is important. If you are not using any character symbols for plotting your different points in the graph, then this font will not work. It will only work if I am using some symbol equals to, let's say, A. All the points in my graph are being displayed as A. And for displaying A, I can make changes in its look. Font is being used for normal font or bold italic or simply italic. You can see one example in the next slide. Like here, In this we have used font equals to 4 value. If I will make use of font equals to 4, it will show you a graph like this. What kind of change it is showing? Rather than using a round symbol or using a square or star, it is using character as a point in your graph. A. And as I have specified font equals to 4, and 4 means just look at all these 4 points. If you are giving it a value font equals to 1 means a normal font. If I am using font equals to 2 means it will make it bold. A will be displayed as bold character. If I will use 3, it will show you italic. And if it is 4, then it will make it bold and italic. So the point to remember here is, if I am using this PCH equals to some character symbol, only then you will have to use here font equals to 1 or 2 or 3 or 4, your choice. So it will pick only 4 values. Font equals to either 1 or 2 or 3 or 4. These are the 4 options for the font style, you can say. So next is CEX argument. CEX argument works for the size of the point that you are displaying. Like I have used the symbol A. So I have already seen that how to make the font style changes using the font argument. But if you want to increase the size of this A in your graph, so you can use CEX equals to 2 or 3, because if you will keep on increasing, it will show you your points so large in size, so that is not required actually. So put it either 1 is default, make it 1.5 or 2. So you can try this and then decide what value you want to give. So you can see the difference that if you will, I will make CEX is equal to 2, this argument will help in increasing the size of the points. Next comes LTY, line type. So in your graph, the important thing is by using which symbol you are displaying your points and how those points are connected in your graph. Earlier it was a solid line. So for solid line, you will have to use a argument LTY equals to 1 only. And 1 is by default, solid line. So you can make changes. You can make it 2 for dashed line. You can make it 3 for dotted line. Dash dot, it will be displayed using 4. And if you want bigger dash, the size of the dash is comparatively large. So in that particular case, you can use long dash. So there are 2 ways. You can specify the argument value either by specifying it using numerical value 1, 2, 3, 4, 5 options, or you can also specify LTY equals to double quotes, and within double quotes you can write solid. So I have given one example at the end of this slide. So there are 2 ways to modify the line type, either LTY equals to 2, that is numeric way to assign the value to this argument, or you can specify it using the name of that particular line type, like dashed or dotted or long dash. So it is always given in double quotes. You will have to make use of this. As and when you are assigning some value that is character string, you will have to assign using double quotes. If it is a simply numeric value, whether it is font or it is CEX argument or it is a type argument, you can always go ahead simply type equals to 1, CEX equals to 2. You need not to make use of double quotes. Then comes color. So color is an important argument which will help you in giving a color to the line or to the font or to other elements of your graph. So if you want to see how many colors are available in R, so in R console, you can simply pass this command colors, COLORS, and simply parenthesis as you write a name of the function. So this colors function will allow you to see all the list of colors. And if you're interested in giving it using some numeric value, color equals to, let's say, 2. So what it will do, color equals to 2 means it will show you red color. If it is equals to 4, 4 means blue color. Or I can write the name of the color COL equals to, within double quotes, blue. So these are the two ways through which you can assign the color to any specific points and lines. So you can note down the example for this. Plot temperature, comma pressure, type equals to, let's say, B. B means line as well as points, and COL equals to red. COL equals to red means it will display your points and lines in this particular color. Then comes line width. So you can also specify that along with line type, that is LTY argument, you can also use LWD argument, which is used for displaying the particular line in your graph with a varying width. In this example, I am using LWD equals to 2, so it will enhance the width of the line displayed. So for increasing the thickness of line and points, you can make use of this attribute. And just for revision's sake, till now we have done various kind of attributes testing. So you can just go through quickly. The first example, simply temperature, comma pressure, type equals to P for making the graph with points. If I'm using type equals to L for making the graph with lines. If I'm using type equals to B, B means graph with both lines and points. PCH, another argument I told you, it is having values between 0 to 25. So either you write PCH equal to 5 or 2 or 3, or you can display the name of the character that you want to display within double quotes. So it is having all those examples here displayed. And font attribute only works with the symbol which is character. Font equals to 4 means if I am using PCH attribute equals to A, character display of the points in your graph, then only font will work with this. So these are also for your quick revision. We have used another argument as CEX. CEX was for increasing the size of the points in your graph. And then we have done with properties of lines, that is LTY, line type, and we have done it for line width, LWD. And another argument that we have covered for changing the color of points and lines in your graph is your color argument. So these are certain basic things or basic arguments that we can use in the plot command. Now comes another set of elements that we can modify in our graphical analysis, that is title and subtitle of a graph. So till now we are simply talking about how you can go about creating a simple graph. We are not proceeding to pie chart or histogram or bar plot and so on. So these are all simply about when we are plotting between two variables along x-axis and y-axis, and how we can change the properties of different graph. So on the whole, in title and subtitle also, you can modify three kind of things. You can modify the color, you can modify the size, you can modify the font. Font always means font style: normal, bold, italic, and bold italic. So as I have done it with respect to different symbols, I can also do it for my title of the graph and subtitle of the graph. So in the first case, first we will cover how to add the title of a graph. And for that purpose, we are having an argument as it is written here in the plot command, main, M-A-I-N. Main is the argument in the plot command in R language, which allows you to give your main title to the graph, which is always displayed at the top. As in this case, I am choosing the title of a graph as pressure versus temperature. So by using this argument in the plot command, plot temperature comma pressure comma main equals to, within double quotes you write down the particular title of graph. So it will be displayed at the top of your graph when you will execute the same command in R console. And then come to color, font, and what was the third one? Size. Fine. So one interesting thing here is rest of the things will remain same. Only I am making certain changes like col.main. Just look at this command, col.main equals to 3. So what does it signifies? It signifies that I am going to change the color, but about what? I am going to change the color of the title of my graph. So for that purpose, I will have to make use of col.main equals to any numeric value. And if you want to specify any particular color, then within double quotes, red or blue or green or sky blue, you can see the whole lot of color list in R console. By passing the command again, colors. Colors command will help you in seeing the list of colors. So these are the two ways. Either you simply make use of numeric value, and if you want to give certain specific color, then you can specify the name of the color within double quotes. Character string will always come within double quotes. If you're not giving it, it will show you an error message. And then comes next thing that we are going to do is size. Size of the title. So if you're not convinced with the size of the title, you can use cex.main equals to 2 or 3 as you feel okay for your graphical display. So that will help you in enhancing the size of the title. So the complete command is written above, plot temperature comma pressure comma main equals to the complete title cex.main. Don't forget to use this dot main. Otherwise it will not understand to which element of your graph you are going to make the changes. So cex.main will help you in deciding that you are interested in changing the size of the title. So similarly, what was the third element? The third element that I want to modify is the font style. So my title is pressure versus temperature. I have modified the size to 2 or 3, and I want to, let's say, I want to show it as italic style. So I will have to use font.main equals to 3. And if it is bold italic, it will come as font.main equals to 4. So in this manner, we can apply color, size, and font, these 3 properties to the title of your graph. And similarly, if you want to apply it to subtitle which we always display at the bottom of the graph. So for that purpose, there is another argument in your plot command, and it is sub. Write down sub equals to, within double quotes, you can specify any subtitle for your graph. Vapor pressure of, one word is missing here in the slide, vapor pressure of mercury as a function of temperature. It can be any subtitle depending upon the data set which you are using for displaying your graph. So in this manner, I can modify again the color, size, and font of subtitle also using sub dot, color dot sub, cex dot sub, and font dot sub. The only change will be the preceded word. Rather than using color.main, cex.main, what I will do, I will make use of again for changing the color of the subtitle as col.sub equals to 4. So it will make use of the color 4, which is in the list. I think it's blue. So it will show you the subtitle of your graph in blue color. Similarly, subtitle. So you should always remember that the main title should be displayed in the higher size. And if you have already opted, let's say cex.main equals to 3. So your subtitle should be lesser than that in size. So that's why it can also be given in points, 1.5 like. or it can be whole number 1 or 2, but not more than that. It will not look good in your graph if you are going to choose your size of the subtitle as 4 or 5. It will show you in quite bigger size. So always choose it comparative to your main title. And last one, that is font.sub. So you can write parallelly both these things. For main title, we are having main argument, and for the subtitle, we are having sub argument. And then we can make the changes in their font, size, and color. These three things we have covered with respect to subtitle and main title. So this is all what we have done in this section. How we can change color of title using col.main, any numeric value, then size of title, cex.main, then font of title, font.main, similarly for subtitle. So it's a quick summary. Those who want to just recheck the things that we have done with respect to changing the title and subtitle of your graph, you can just have a look on these all commands. So for your help purpose, I have given as a summary at the end of this. Then another section that we can modify here is modifying the axis of a graph. If you remember in your application softwares like Excel, it's a job of just a few seconds. Always in your graphical interface, you just go about putting certain values in the graphical interface, you click on OK, and it will apply the same to the given graph on the screen. But in our language, it's not like this. You can see that using the plot command, we will have to give each and everything using a particular argument with its value. Only then it will apply. Otherwise, what it will do, whatsoever default values are being set, that will be applied to your graph. So next section is how we can change the properties of axis of a graph. So normally when you're displaying your graph between x and y axis, so I do have axis value and certain labels which I'm interested in. So similarly, I can make changes to the axis labels. I can give it accordingly. Otherwise, by default, it show you as x-axis or y-axis. If you want to give any name, like in this particular graphical plot, the x-axis label is age in years. And on the other hand, along y-axis, what it is showing you, weight in kg. If you are not going to give it in the plot command, it will choose by default. So you can make changes in the axis labels, and the values displayed along axes are 5, 7, 9, 11, 13, 15. So these are all the axis values. Similarly, along y-axis, we are having 15, 30, 45, and 60. But if you want to change its properties, you can do it using arguments that we are going to discuss in next few minutes. So let's see the first thing, how we can add the labels first. X label and Y label. So which label rather than a default one you want to add? Like in this case, I'm saying plot, temperature, comma, pressure, comma, X label. XLAB is the argument. Similarly, YLAB is the argument. And then give required X label and Y label. And remember again, it is to be in double quotes. Only within double quotes it will accept the text string. So you can give your graph x-axis and y-axis labels using the command. Then comes to again the color of this particular label. So if you want to apply a particular color to your labels, like in this case, it's showing you in violet color or somewhat similar to that. So you can put the value col.lab. So it's very easy to remember also. And if you forget the name of the argument, you can just look into the help of plot command and its arguments. So earlier what we have done, col.main means we are going to change the color of main title. col.sub means we are going to change the color of the subtitle. And col.lab means I am looking for changing the color of the labels, not specifically X or Y. It will apply the same color to X label and Y label. Next comes to size of the labels. So if you want to modify, like in this case, I have increased the size of the X and Y labels comparative to the earlier display. So for that again, cex.lab. So it will modify the size of the labels displayed on your X and Y axis. And then comes the font style. font font.lab. So you can see that it is applying the same kind of argument. The only difference is it is followed by .lab, that is label. So accordingly it will apply. So in this manner you can make changes in the labels of your axis. And then comes limits. It is a very essential part of your graphical display of graphs. Normally, if we are not specifying any limits for X axis and Y axis, it will do it by default. So if we are interested in giving X axis limits and Y axis limits as per our own choice, so we will have to specify it using a numeric vector array. So, sir, can you give me an idea whether you have done how to specify numeric vector array? Because in this course our sessions are very less and it's difficult to cover all the essential basics of R in a single session. But for your convenience, I have added one example in the slide. You can note down this. So what we have done, plot temperature comma pressure and XLIM. It is for X limits. Means I am going to specify certain limits for the X axis values, right? That is displayed along the labels. So X limit equals to C within brackets 150 comma 300. So what it is telling? It is telling to the plot command that along x-axis whatsoever x-axis values I am going to consider, the minimum is 150, it will go up to 300. And similarly I can specify the y limits equal to C within brackets 0 comma 200. So it will initially use 0 and it will go up to 200 along the x-axis. So in this manner you can specify this equal to C means it is the syntax for defining your numeric vector. And I am using only two values, the starting value and the ending value. So I will assign this particular limits to the y limit and above to the x limit. So you can make changes in this syntax. X limit equals to C within brackets you give the lower value and the highest value. So in this manner you can set the lower limit and the upper limit for your x-axis and y-axis. Then comes color of axis values. So in this case col.axis, you can see that all the values that are displayed are right now in cyan color. So this can be done using the col attribute again .axis. So all the axis values will be displayed using this particular color. Earlier we have done it for labels, axis labels. Right now it is applying the color to the axis values. So default is black. If you want to make changes you can do. And similarly size cex.axis. When you are writing cex.axis means axis values, and when you are writing cex.lab, lab means for labels, x-axis label and y-axis label. And similarly font.axis. So till now what we have done it for main title, all these property changes we have done it for subtitle, we have done it for labels, and we have done it for axis values. So in this manner we have learned that plot command is having lot of possibilities for modifying your graph, particularly on the screen. Then I'm going to give you certain another data set idea. So there is one more data set we are going to make use of, that is IRIS data set. IRIS data set is one of the very popular data set that the researchers are using for doing their data mining task and for graphical analysis. It is a flower data set which is having different type of species for this particular flower, like Virginica setosa and so on, and it is having different attributes like sepal length or sepal width and so on. So what you can do, before you plot a graph, just see its structure. Again the method is same, str within brackets name of the data set. So if you know the name of any data set, that is either preloaded in R or you are going to use it. So always see its structure. str within brackets name of the data set. And then followed by the command attach command, attach within brackets name of the data set. Without using attach command you cannot display. So it should be used once before running the plot command. And sometimes the key point to remember here is sometimes it doesn't work smoothly. So you can just close your R console and you can open it again and you can rerun the same commands if it is showing some error. Next, come to how we can display certain additional things along x-axis and y-axis. Sometimes we want to signify certain important points, like along the temperature axis, I want to show some temperature is low. I want to put label over there low, medium and high. And similarly, we want to show certain labels along the y-axis. So for that purpose, you can change the axis values using the axis command, AXIX command, and it makes use of additional arguments. The first argument is side. So you will have to tell on which side of your graph. If it is 1, 1 means bottom. If it is 2, 2 means on the left hand side you want to display, and 3 means top side, and 4 means right side. So the first argument simply is side, and second one is at argument. At which specific x or y axis values you want to show a particular label. If say the temperature is simply, let's say 10, 20, 30, 40, 50, and at a 10 temperature I want to show a label low, and at another temperature, let's say 30, I want to show medium, and at let's say 45 or 50 I want to say high temperature. So this kind of assigning of labels along the axis can be done using the axis command. So just see in this graphical display what it is showing. On the x-axis it is showing you low, medium, high. So how it is done? After the plot command you can run the axis command. It is separate from this. So in this particular case I am plotting the graph between two attributes of IRIS dataset, sepal.length and sepal.width. So the plot is between sepal.length and sepal.width, and x is equal to f. Note down this new change in this function. X is equals to f means, are you seeing any axis here? Is there an axis? X-axis, y-axis, where it is? It is not available. Equal to f means it will not show you. It is only showing the plotted points. So x is equals to f means it will discard the x-axis and y-axis, only showing the points plotted. And I have added additional axis here at the bottom, which is having 3 labels, low, medium and high. But at which point it will show you? So it is showing you that sepal.length is along x-axis, sepal.width is along y-axis, and along x-axis there are certain points whose values are 4.5, 6 and 7.5. Just see here in this command, at attribute. Side is 1 means bottom of the graph, comma, at equals to C, and within brackets I am specifying certain values. The first value is 4.5, the second value is 6, and the third value is 7.5. It means out of the available x-axis values, it will choose these specific sepal length values and there it will display what labels? So the third attribute here in labels equals to C within brackets, the first value is low, comma, the second value is medium, comma, the third value is high. So how it will correlate between two? At point 4.5 along x-axis it will show low. At a particular x-axis value 6, it will show medium. At a particular value 7.5, it will designate it with label high. So in this manner, sometimes we do have certain specific requirements while plotting the graph. So there is an axis command for that, and it is using 3 arguments. The first one is side, the second one is at, and the third one is labels. So you can apply it to x-axis along or y-axis, both ways. If you want to display the same thing along y-axis, then side equals to 2. Side equals to 2. Just see here. I have added axis. The first argument is 2. The side of the graph. The bottom of the graph is chosen as 1. Left hand side is 2. The top of the graph is 3. And on the right hand side is 4. So side means at which side of your graph you want to display the axis. And at means at which specific points you want to designate it with label. Fine. So side equals to 2 means I want to display this labeling along y-axis. Fine. Then comes box. Sometimes you need to draw a box around your plotting. So for that there is a box command, box function. So this box command will be run to draw a particular square around the plotting. So just remember one point. Plot command is run first, axis command is run, and then at the last I am drawing the box. After plotting the graph, it is followed by box command. So sometimes we do mistake, a very silly mistake, that we run box command first and we are looking where it is. Nothing is coming. So first you plot the things at the axis and then you bound it with rectangular box. So that will be done using the box command. So this is a summary for you, what the things that we have applied to the axis of graph. So we have done it for axis labels. You can see how to add X label and Y label command argument. Then we have done the color of axis label, and it was done using the col.leb argument. And then size, it was done using cex.lab, and the last one, that is font.lab. And similarly, we have modified the X limits and Y limits, and then we have followed by the color of axis values, size of axis values, font of axis values, and axis values for labeling the X or Y axis. So this is all what we have done in this section regarding modifying the axis of a graph. So there is one more slide. If there is any query, you can ask for any remote center if there is any query.
Yes, so, till now at all the remote centers, we have any question?
Okay. So, dear participants, till now we have seen that when we are handling with certain simple graph, so we can certainly modify its properties. And you have seen that it's not that easy as we normally do it along with any application software. So, on the similar pattern, we are having certain other elements that we can add upon. And in this category, we are having how to add a legend on a particular graph. So I am going to take the same example of the iris data set that we have just used for drawing a plot between the sepal.length attribute and sepal.width. And there is one more additional attribute in this data set which is named as species. So if any one of you understand that in data mining we classify our data using a class or a label attribute. So in this iris data set there is one last attribute which is named as species. So species is telling with respect to every record in your data set that a particular flower having certain properties is named as Setosa variety. Similarly, a particular record labeled with species versicolor and virginica. So in this section we will see that if we are having such kind of classification available in our data set, so how we can go about drawing a legend or adding a legend on our graph so that we can show that the different points that is being plotted by us in the graph are of different categories. So for that there is a command in R language. It is known as legend command. So just see here in this example what we have done. The command for plotting the graph will remain same, plot command, and in this we are using sepal.length. You can note down this example in order to understand what we are going to do. Sepal.length, the first attribute from the iris data set along x-axis, and within square brackets I have chosen species equals to, double equal to sign is here, species equals to Setosa, means while plotting certain points in my graph I am specifying a condition that only plot the sepal.length attribute value if the category for flower is Setosa. Then followed by next argument PCH equals to 3. So you can plot a particular point using a particular symbol. Then line width equals to 2. Color for plotting the points and lines is 2. This is all we have done in the earlier slides. So I'm simply using all those attributes. The new attribute that we are using is this one. How to specify condition. Y label equals to sepal.length and Y limit equals to C, and it is using one interesting feature here, that is I am using that the limits along my y-axis are having minimum out of sepal.length attribute. So min is a function. If you are having any attribute in your data set like sepal.length, it is having certain set of values. So out of those values, a value which is minimum will become my minimum lower limit for the y-axis. Similarly, max function tells you the maximum out of numeric values. So I am interested in choosing y-axis limits as minimum out of sepal.length. So I am using here a function. If you remember the earlier slide, we have given x limit and y limit. There I have specified the static values like x limit equals to c within brackets 150, 300. I have done it earlier. But right now I am saying not a static value, but it will find out using a function minimum out of sepal.length attribute. And similarly, what will be the upper limit for y-axis? Maximum out of what? The attribute values which are being displayed along the y-axis. It is sepal.length. So maximum out of that is your upper limit. So after plotting a simple plot like this, so it will show you these points with red color. The effect of running the earlier command which I have just shown, this complete command, it will show you a display like this. So you can just see for a moment what it has done. Sepal.length is along the y-axis, and the values that we have chosen, the lower limit is showing 4.5. So it might be the lower limit for the sepal dot length attribute values in your data set. And similarly, the highest value it has chosen. So it will show you all the points. So you can note down one important point why I have selected the limits for this. Any point beyond these limits will not be displayed in your graph for sepal dot length, and variety is setosa. In my overall records, I am having different variety of colors, setosa, virginica, and so on, 3-4 different varieties. But right now I am interested in plotting only the setosa variety, which is being written here. Sepal dot length, species equals to setosa. I have restricted in your research. But it's not all. First, you will have to go through the basics of our language. Then what kind of research you are doing, accordingly you can pick for a particular analysis. And do we need certain graphical analysis over there? Decide what kind of plot you are interested in. Yeah. So graphical analysis comes a bit later after going through the basics. So is it connected now? Okay, sorry for the interruption. It was disconnected from our end. So we have left our discussion. So let me repeat the thing, the previous point that we have done. So I was showing you this plot, which we have just created with respect to a particular species of flower, that is setosa. So all these red point symbols are representing this particular variety. Then there is a provision to add on the points in my plot. And for that, we are using next command, that is points. Points command is there, and point command is again using certain attributes. So what we have done, points within bracket, sepal.length, square bracket. Square brackets are being used for specifying the condition. I am specifying a particular condition on an attribute. Sepal.length is one attribute in your data set. I want to specify certain condition, and condition is species of that particular record should be only versicolor. If not, it will not show you in the plot. So this time I want to add on some new points with the color green, and the variety is species equals to versicolor. PCH equals to 8, again a particular symbol. As you can see that earlier it was showing you plus plus symbol. This time it is using some star symbol or asterisk symbol, and then color equals to 3. It is using green color. So just in order to make a difference from the earlier points. So remember one thing, that once you have run the earlier plot command for showing the initial points of your plot, then you will have to follow it by using the points command. You can see in the display, there are 3 commands. First command is plot. Second command is points. Then one more command. These all commands we have run on our console. Point command helps you in adding the points. Are you getting my point? Plot command is to draw the basic plot, and then if you have certain more points to add on in that plot, you can add them using the points command. So it is just a kind of adding points with some condition. So I have added some new points for the species versicolor. I have added some more points with the species virginica. So on the whole, what I will get after running all this kind of plot. So you can see that there are certain points which are red in color, symbol is different. There are certain points which are green in color with some different symbols. And thirdly, we are having this star symbol. So all are representing different varieties of flower. Fine. So now comes the need of legend. How to represent, what kind of points they are. So I need to add a legend. And here comes the command in our legend command, and it is having different arguments. The first is location. The second is a particular legend that you want to draw, and PCH attribute, LTY and COL. These are earlier ones. So you do it using example that will help you more. Like in this, one example is given. So just try to understand what we have done. Legend within parentheses, top right. Top right means I am interested in telling the location. Location argument is taking the value top right. Again, remember, as it is a character string, within double quotes you write it. Comma, legend equals to. Normally in a legend table, as you were asking me, in a legend table you will have to specify the different types or the different classifications. So in this particular case, what kind of classification I am having? Some flower varieties. So all the flower varieties that I want to designate in the legend as an information, I will write down as a character array. This is known as character array. Legend equals to C. Earlier in previous slides, we have used some numeric values. But right now I'm having some flower varieties. So all the names will come in double quotes. Setosa, comma, versicolor, comma, virginica. If let's say these are the name of persons, Ram, comma, Mohan, comma, Sham, anything you want to write. Numerical value is always simply without quotes separated by comma. If it is a character array, all the values should be in double quotes separated by comma. Then PCH equals to, again, see what I'm using, it is a way to represent numerics. So it is associating that Setosa using a particular symbol. Symbol was plus. next variety is versicolor. I am saying 3,8. So means 8 is corresponding to versicolor. Using only the single argument PCH, but right now it is having 3 values, 3, 8, 11. So how it is using? It is using a particular symbol with numeric value 3 for setosa. It is using 8 as a symbol. 8 के corresponding जो भी आपका symbol था list में वो use करेगा versicolor के लिए. Then thirdly 11 के corresponding जो symbol है वो आपका जो star वाला आ रहा है ऊपर blue color में वो virginica के लिए. इसी तरीके से कलर बता दिया हमने कि जितने भी मेरे डिफरेंट कैटेगरीज हैं ग्राफ में उसमें पहली जो आपकी कैटेगरी है सेटोसा उसके लिए कलर लिया है 2 वाज रेड. वर्सिकुलर के लिए मैंने लिया 3 वाज ग्रीन और virginica के लिए 4. So using numeric and character array it becomes so easy. Otherwise you will have to tell explicitly separately. So that is a tougher job. In this manner, within a single numeric character and character array, you can simply tell for which category, which color is used, which symbol is used. So the task is quite simple. And how to run this command? After plot command. I don't know whether it is visible or not. Otherwise, you just read the command that is given in the slide, legend command. Just like points command, it is to be followed after plot command. It's not a part of within plot. After running the basic plot command, you add on the legend on that. I'm adding on certain points using the point command. We are adding legend on that using legend command. If you are adding a axis command, fine. So what is this? This is adding additional elements to your graph. I have already created a basic graph, but I am interested in adding legend, some axis values, some other elements. So you can go about using legend. So just see what it will do. The location is top right corner. The name of the legend classification is setosa, versicolor and virginica. Just look at the labels along setosa plus along with versicolor asterisk mark, along with virginica star. So in this manner you can add on legend in your graph in R language. So it's a quick summary for you. Just check it out what we have done. Basic command that we have run covering all the basic argument values. Then we have added some more points for the versicolor variety using points command. Then we have added some more points on that plot for the virginica variety. And then we have added at the end legend. So always remember that legend is a requirement when in my graph I am having some different set of plottings. If all points are of the same color, you may not be needing the legend. But if you have different category of data, in the single data set, the data is categorized among different classes. Fine. In that case, we need a legend in order to understand our plotting. And then comes the requirement of some special graphs like pie chart, bar diagram, or histodiagram. So as long as the time will permit me, I am left with 15, or we can extend it to 5-7 minutes more. So in that, I will give you a quick review of some type of plots. So till now, we have simply plotted a main basic graph and we have modified all the properties. So let's see how pie chart can be drawn. So in pie chart, again, you will be needing a data set. So this time I am using empty cars. Note down, empty cars is one of the, again, a data set. I'm going to draw a pie chart by taking data from the empty cars data set available in R language that is preloaded. Fine. str command is used for seeing the structure. So just look on the side display. It is showing you all the different variables. So on the total, it is having 32 observations and 11 numeric variables. Observation means different records. And 11 numeric variable means I am having different 11 variables in each single record, corresponding to which you are having value. So just like a two-dimensional matrix, you are having 32 observation and in every observation you are having 11 values. corresponding to different 11 numerical variables. So str command allows you to see the different variables, their data types, and their corresponding values further if you are interested in. So just note this command mtr and this less than sign hyphen. Sir, any idea about this, what we are doing? Just like in other programming languages, empty is a variable in which I want to assign some set of records out of empty cars. So let's say empty cars is having 100 records. Empty cars is a data set having 100 records, right? If somebody says, okay, extract the top 5-6 records. So in that case, our language having a command head command. Head within brackets name of the data set. What it will do? It will extract the top records. Limit is inbuilt fixed. 6-7 records it will pick up from the top. Head means upper records, right? And after picking the upper records, what I will do? I will have to save it somewhere. Just like other programming languages, you do x equals to 5. Fine. Name equals to, what's your good name? Avinash. Name equals to double quotes Avinash. So similar to that, if you want to save set of records somewhere, so what you need? You need a data frame. We call it data frame. In our language, this data structure is data frame. So I am going to assign the top 6 records extracted from where? Empty cars data set, and I will assign it to empty variable. Fine. So just see in the display. In the earlier command, I have taken the top 6 records from empty cars data and I have assigned. It's not equal to sign. Our language may, if you want to assign this less than and hyphen. Arrow, just like an arrow mark. So what it is doing, it is extracting the top records using the head function and it is assigning to the variable empty. Why I am doing all this task? I am doing it in order to draw a pie chart, and for drawing a pie chart I need certain records. So rather than doing it for all set of records, I am extracting the top records from the data set and I am saving it to empty variables. Then you can view what empty variable is holding. So empty variable is holding this matrix type data, right? So this on the right hand side, left hand side, you are having the list of all the car varieties, and on the column side above it is having all the variables names. So corresponding to a particular car, let's say it is a Maruti Suzuki, it's a Honda City, it's a Brezza, or it is some other car. So on this side the name of the car is coming along the row number, right? And on the column side it is showing you different attributes for which it is having a value. So in this manner, empty cars data set is having 11 numerical variables, and out of that I have just picked up observations which are the top 6. And now I will draw a pie chart of this. So just remember, my data is saved in which variable? Empty variable. And empty is holding what? The top 6 records. From which data set? Empty cars. Fine. So unless until you are not having reference to which data you are going to use, it will not draw the pie chart for you. Fine. Attach empty. So I am not going to attach the complete empty cars, but I am going to attach empty. This data frame which is holding these 6 records. Pi within brackets disp. So disp is what? Disp is one of the numeric variable in my empty variable. Disp is not the all. Out of the 6 records, each record is having data for 11 variables. Out of that I have picked the one. DISP, I have picked the one variable, and for all the corresponding 6 records, I will draw a pie chart for this variable. Again, go back and just see what it is showing. it is showing certain name of the cars. And for each car, it is showing data for 11 variables. Out of these 11 variables, I have picked one, the third one. I don't know whether it is visible to you or not. First one is MPG, mileage, CYL, and the third one is DISP. So I have extracted this one. I want to plot a pie chart for this particular third variable named as DISP. It can be anything. Like you are having an employee record. Name of the person, age of the person, city of the person, designation of the person, salary of the person. And if I say draw a pie chart for salary of the person, so you will have to specify the name of the variable. I have attached empty. I have drawn the pie chart for the specific variable DISP. Fine. What is the difference in earlier plot and this? 1, 2, 3, 4, 5, 6. See around the circumference of the pie chart. So it is showing you the pie chart corresponding to the disp variable, but as I have not given any label, it has picked 1, 2, 3, 4, 5, 6. If you want to give specific names, labels equals to row name. So the first observation which was corresponding to a particular car, I will pick its name, its row name. So what it was? Datsun, and one is Mazda, another one is Valiant, and so on. So these are the different names for each individual observation, taken as row name, you can say. Fine. So it has taken name from there itself, from the data set, and it has assigned around the different sectors of your pie chart. Earlier it was default 1, 2, 3, 4, 5, 6. So I was not able to understand this pink color is for which. So I will look into my data set. Okay, let's go back and see. The row number 3, Datsun, and for this it is using a pink color sector. Now my task has become easier by using this additional labels command. Labels equals to, from where it will take the labels? From the data set. Row names for each observation. So in this manner, for drawing a pie chart, as you can see that there is a simple pie command. It's not tough. Pie within bracket आप बता दीजिए कौन से वेरिएबल का पाई चार्ट बनाना है. लेकिन मेन काम क्या किया हमने पहले डाटा कैसे एक्सट्रैक्ट किया ना. Fine. So we have extracted our data from the data set empty cars, the top 6 observations, and I have assigned it to empty variable, and that I have attach empty, and then I have drawn the pie chart with the labels corresponding to each row in my data set. So it is easier for me to now understand the pie chart. Similarly, we are having bar diagram, which is of different types. All of you who are doing your analysis work, they might be knowing. You can draw a simple bar diagram, you can draw a stacked bar diagram, or you can draw a grouped bar diagram. So with respect to R, I need to know how to draw. So for that, we are having a bar plot command. For pie chart, there is a pie command. For the time being, as the time is short, you can note the name of the function in R language. So pie command is for drawing pie chart. Bar plot command is used for bar plot. Hist command, H-I-S-T, for drawing the histogram. H-I-S-T, hist, histogram. So as you can see, in the journal syntax of this bar plot, I am having one argument is X, which is a vector or a matrix. Means bar plot will be drawn for a vector data or for a matrix form data. Analysis is only useful when you understand your data. And for your data, what kind of graphical analysis is needed. If your data is not suitable for drawing a bar plot, it will not draw. Similarly for pie and another kind of graphs. So X should be either vector data or a matrix form. Then comes horiz, H-O-R-I-Z. It is just for displaying my bars horizontally or vertically. You can change the side. It can be set to true If you want to display your all bars, horizontal direction. And if you want to show them just like default vertical, you can leave this. Right? Means in our language kind of thing, you need to convey each and everything which you require through a attribute or a argument in the function. And the third one is beside. So that we will see how it will use one example. Right? So just if you will type the command bar plot within parentheses, I am saying VA deaths, square bracket, comma, 1, square bracket close, parenthesis close. So here I am using another data set which is VA deaths. Fine. So it is making use of data set VA deaths. And I am interested in plotting a bar plot. I am going to take all the rows in that data set, but only column number 1. My problem here in this session is you people are, I think, are not aware of all the basics of R language. R language is having different kind of data structures unless until you are not using those, like arrays. I am having lists, I am having data frames. So in the earlier example, I have shown you how to create your data frame. Data frame is just like a record sort of thing, a structure sort of thing. Similarly, you do have list, like say I say prepare a list of employees and I want to save the information of each employee's name and child's and their salary and all. So you can create arrays, numeric and character, whatsoever is requirement. You can create lists and you can create structures. Structure just like collection of records. So for that purpose, you will have to go through arrays, lists, and data frames in R language. Fine. So in this example, I am using a VA deaths is again a data set. And from that data set, I am going to make use of column number 1. Rest of the columns, I will leave. So it will draw a bar plot for that. Because I said bar plot can be drawn for vector type data and for matrix type data. Fine. So in VA deaths data set, the column number 1 is having different values for that, and it has shown you the bar plot. The command is simple bar plot, but it is making use of a particular data set, and from that data set, the column number 1. Before comma, you can see that I have not written anything. So what does this means? If you are having 100 records, so it will pick all the 100 records, and in every record it is having 10 values or 10 column values. It is only picking the first column value. So just think in terms of 2-dimensional matrix. I am picking all the rows, but I am picking only the first column. All rows, first column values are used for drawing the bar plot. Getting the point? So this manner. Horizontal equals to true. So it will just change the direction of your bars. Fine. Bar plot, simply within brackets VA deaths. So what is the change? Have you noticed? What is missing now in this command? Bar plot within brackets, name of the data set. Syntactically, what is missing? I am taking all the columns. It is another kind of stacked bar graph. Earlier, I was using only the column 1 value. I am not showing here only column 1, but I have taken, let's say there were 5 columns. So it is taking all the 5 column values in each row of the data set. So for that, you can draw a bar plot which is of the type stacked bar graph. Let me go back. It was earlier command. It is for showing corresponding to a single column. Now I am using, let's say 4 or 5 columns for plotting my graph. So the type of the bar plot will vary. It is a stacked bar graph. You can see that different colors are used on grayscale, black and light gray, and that much lighter gray and so on. beside equal to true, the third argument, which I'm disclosing right now. So what is the difference in plot? Beside equal to t means true. All the 5 stacked bars are now beside each other. Rather than one above another, they are beside. So if beside is equal to true, it will display it like this. If beside equals to false, by default, it will show it like this. Getting my point? VA dash bar plot, VA dash beside equal to true, main equals to, main means title of the graph, color equals to 1:5. Just note this syntax. Color equal to C within parenthesis 1:5. 1 से 5 तक कलर की वैल्यू ले लेगा जो डिफरेंट बार्स हैं. फाइन. फर्दर तो हमने किया ही है, पीछे लीजेंड ऐड करना है तो लीजेंड इक्वल्स टू ट्रू कर दो. देखिए इसमें हमने क्रिएट नहीं किया, सिर्फ लीजेंड इक्वल टू ट्रू कर दिया. उसको ऑटोमेटिकली पता है बार ग्राफ के अंदर मोर देन 1 हमारे इसमें है. ठीक है. हिस्टोग्राम आपका लास्ट जो है इसमें ये जैसे हमने एक रिवर्स डाटा सेट है उसके ऊपर किया, उसका स्ट्रक्चर देख लिया आपने. ठीक है. हिस्ट कमांड नोट कर लीजिए, बस हिस्ट कमांड है जो आपकी, जिससे आप ड्रॉ कर सकते हो. ये हिस्टोग्राम आपका ड्रॉ हो गया. हिस्ट विद इन ब्रैकेट नेम ऑफ द डाटा सेट. Histograms with frequency are not comparable, especially when they are created with unequal number of observations. So in that case, histogram with density is applicable, which can be obtained by setting the argument frequency equals to 4. So if you are having unequal number of frequency, so in that case, you can make this frequency attribute equals to false. And breaks, you can specify the breakpoints in the histogram command. Frequency which is varying rapidly from 0 to 1500, and after that it remains almost same. So you can see that the width of the bars, is it same or varying? The last bar which is having very short height, it is going up to 4000 last. So if some frequency is varying at different points and later on it remains same, so its width is more. So I have decided certain breakpoints. The first is 0, then 500, 0 to 500, 1 bar, 500 to 1000, second bar, then 1500, the third bar, and then last is 4000. So last bar in my histogram is going up to 4000. So in this manner, in hist command, we are having the first argument, name of the data set, the second argument was frequency, which you can keep true or false, and the third one is breaking points. So in this manner, we have gone through this. Fine. So I hope this much, I have lot to share with you, but the time doesn't permit. If I will start with another topic, similarly what you can do, you can even draw multiple plots, right? You can draw multiple plots also. So I will show you just one slide, and through that you can get an idea. You can note down this. Sometimes what happens in our research, that in a single plotting window, I want to show 2-3 plots, one below another, right? पहला प्लॉट है, दूसरा प्लॉट है, उसी डाटा सेट के ऊपर एक तीसरा प्लॉट है, और मैं कंपैरेटिव एनालिसिस करना चाहती हूँ. So you can draw more than one plots in the single plotting window. And for that you need to tell which layout you will decide. So the first method is that you can tell MF row and MF column. MF row and MF column. And then I have run just 3 commands. I have drawn histogram on 3 respective variables, MPG, disk, and weight. These 3 attributes are there in the empty cars dataset. So I want to show all these plottings in a single plotting window. So just like dividing your main window into 4 parts or 3 parts and show in each window a different plot. And each individual plot is a result of different plotting command. Are you getting my point? So what you will do, first you will have to tell PAR, write down the last command first, PAR mf row equals to C 3,1 and bracket close. So it is telling that I am going to draw 3 plots in a single column, means one above another, right? So 3 plots, and from where the 3 plots are coming, one is due to hist command within bracket mpg, another plot is coming due to the command hist dist, and third is hist width, right? So first you specify the layout and then you give your all the plot commands. So it will show you all the plottings one below another, just like in a single column. And another method is using this layout command. So one of these you can use. That one is easier, you can understand. But if it is in a matrix form, like 2 cross 2, my plotting window is divided into 2 cross 2. But I do have only 3 graphs to show. So what it will do, the first 2 columns in my plotting matrix will be taken by the first plot. And then second row, first plot will be taken by the second plotting, and second row, last plotting area will be taken by the third plot. So with these words, I am winding up the session, and if any remote center is having any query, you can ask. So similarly, you can do many other graphical analysis. You can add specific points that is of interest. You can draw a line like in regression. You can plot a curve and so on. So in 1.5 hours, it's difficult to cover all the aspects, but I have tried my best to give you an idea about how you can make use of R language for doing some graphical analysis. So as a summary, first of all, you need to understand your data set. Understand your data set, see the structure, attach the data set, and then choose the right kind of plot, whether it is pie chart or a bar chart or a simple graph you want to plot or a histogram and so on. And then modify the properties using different plot command arguments. So any query from any center before we leave?
Yes, we have any questions from any nodal center?
No, sir. कोई बात नहीं, कुछ भी नहीं है वो तो पेपर भी करने शुरू किए।
हाँ जी मैम, एक रिव्यू पेपर किया है।
अच्छा वो तो लिखा हुआ है, हाँ लिखा है।
तो मैंने मेंशन इसलिए किया कि पेपर लिखने में भी लेटेक्स से काफी
हेल्प मिली। मेरी सुबह डॉक्टर रामाकृष्ण से बात हो रही थी, कहते मैं मतलब लेक्चर नहीं ले सकता, बट उन्होंने अपना थीसिस, वो भी काफी साल हो गए पीएचडी किए, उन्होंने अपना थीसिस लेटेक्स पे किया।
मैंने
वे ही वाज टेलिंग ना, मैंने कहा ये तो रिसर्च पेपर कोई भी करना हो तो इट्स वेरी यूजफुल। हाँ जी, जब आप ग्रीन सिग्नल देंगे तो हम शुरू हो जाएंगे। ये कैमरा ना बाद में इनकी और भी अच्छा, चलो पहले हाजिरी करते हैं। अमित वाला शानों का ठीक नहीं चला है। So very good afternoon to the participants at various centers. Let me hear from various centers. Are you clear about the task which we have given for tomorrow's presentation? I'd like to hear first of all from Kite Ghaziabad. Kite Ghaziabad. MS University Baroda.
Yes, ma'am. Kite Ghaziabad.
Kite Ghaziabad.
Yes, ma'am.
Yes. Are you clear about the task you have to present tomorrow?
No, ma'am. Because
Yes.
at our center we are not able to download this R.
की आवाज क्लियर नहीं है सर।
Ma'am, your
आपका
Yeah, but-
कैमरा भी ऑफ है शायद।
hello.
पार्टिसिपेंट्स
Am I audible, ma'am?
आपका कैमरा छत को दिखा रहा है, पंखे चल रहे हैं आपके। आप प्लीज पार्टिसिपेंट्स की ओर कर दे कैमरा। थैंक यू।
Ma'am, we were not able to download this R. We have several times requested to sir that we are not able to download this R. There is some problem in this software.
और आप बताइएगा।
Ma'am, we were not able to download this R software at our center.
तो बाद में आप ट्राई कर सकते, ठीक है। यहाँ पर तो आपको एक ओवरव्यू और ब्रॉडली अवेयरनेस दे दी गई है, so you can later on download and practice on that. You can't have so many practice sessions for various softwares. We are just giving overview of the things. Tomorrow again we will be having SPSS. Just in this very session we will be having LaTeX, but everything you have to practice afterwards.
Okay, ma'am.
I was just asking, are you clear about the task which you are to present tomorrow?
No, ma'am, we are not clear.
Hey, then I just announced at 11:30 that you are to write the statement and tell the statistical techniques which will be used for conduct of that research.
Ma'am, your voice is not coming clear. We are not able to hear you clearly.
Okay, am I now audible?
Just a moment, ma'am. Let me check. My end.
Am I now audible?
Yes, ma'am.
Okay. You are to write the problem statement which might be you have done earlier. You are to then write the statistical techniques which will be used for that. Is it clear?
Pardon, ma'am.
You are to write statistical for the problem selected.
And the main part we are missing. When you speak the main part of the task, your voice is gone.
This is a very small task. Select the problem which might you have already presented also. you might have written the hypothesis. Now you want to come to statistical techniques.
If I
Just adding statistical techniques to the earlier work. That's it. You have done earlier work. Add statistical techniques.
the problem we have got earlier, we have written the hypothesis for that. Now we have to
You are write the statistical techniques which you will be using for verifying that hypothesis. Let me now go
we have
MS.
to we have to do that on the t-test.
Excuse me, sir, what you want to convey?
We have to apply a t-test over that hypothesis.
It can be any. I don't so. It depends on your
We have
hypothesis.
to verify that hypothesis. We have to verify that hypothesis. Start with that.
Research problem. I think we started with that. कि research problem है, then our review, then hypothesis you generate, then you come data collection, testing. For testing, you go for some statistical analysis. I think this is that which we are doing right from the day one, right? So you are just adding, but you have already done the work. You have to add what type of statistical techniques will be used. That's it.
Then how to get the data for that problem? Because
I am not
the problem.
saying that you will analyze the data. I am saying write the technique you will be using.
Okay. Thank you.
Okay, you are not administered your test. You are not administered your things. Okay. Let me hear from MS University, Baroda. Are you clear about the problem? Sir, am I
Hello.
audible to you?
Yes, madam.
So,
Yeah,
okay.
you have to take one statistical problem and decide the
Right.
technique for solving that.
Technique which will be used for the problems you have already selected. Right? You have made the presentations that went well. So go ahead with that. So I move to this City College Jalandhar, City Group of Institutions Jalandhar. Are they here?
Hello, ma'am. Good afternoon.
Good afternoon.
Thank you, ma'am.
Yes, sir.
Yes, ma'am. We are very clear.
सर आपके कितने लोग आ गए हैं?
मैम यहाँ पर अभी लंच चल रहा है तो अभी आ रहे हैं सर.
हाँ प्लीज हम अपना लेक्चर शुरू कर रहे हैं तो प्लीज आप जल्दी बताइए. फिर एक नया सॉफ्टवेयर आज डिस्कस होना है so you will not be able to understand them.
Okay, ma'am.
Okay, RTU quota. नहीं मॉर्निंग में हो गए थे दोनों लेक्चर्स में. फिर गांधी इंस्टीट्यूट वो भी नहीं कनेक्टेड है. और कौन है? अच्छा चौधरी देवीलाल यूनिवर्सिटी. हाँ जी सर. हाँ जी आपके पार्टिसिपेंट्स आप पहुंच चुके हैं.
वापस क्यों आए? खाना खाना चाहिए था. नहीं सर हमको ना वो जगदीश है ना उन्होंने गलत गाइड कर दिया. फिर गए हुए तो खाना तो खा खाऊं नहीं उठता है यार. वाला क्या ये नाम मुझे ऐसा कर दिया नहीं खाना. क्यों भी जाने चलो बीच में हूं सारे के सारे साथ
Okay. Well, very good afternoon to the faculty at various institution. I will like to introduce Preeti Kumari. She has done MTech from MIT Agartala and is pursuing her PhD in Electrical Engineering Department at NITER. Her area is biomedical instrumentation. She has also published one review paper in Elsevier Science Journal, and she is doing work using Altex software only. So she will just demonstrate how you can use this software for writing of your thesis report or even for your various research papers also. So I request her to interact with you. Thank you, ma'am.
Very good afternoon to all of you, all the participants at different centers. As ma'am already introduced me, so let us start with the today's topic, LaTeX. LaTeX is actually a very vast topic, which we cannot discuss each and every details in this short duration. So in this session, we will discuss only the basics of LaTeX. But I'm sure that will be sufficient for anyone to start working with LaTeX. So first of all, you must know what is LaTeX, why we are going to learn this, and why it is so important. What are the advantages of this software, of this programming language over other document preparation systems. So LaTeX, which is pronounced as LaTeX or LaTeX, is a text-based document preparation system. It's basically a document preparation system, just like MS Word. Okay? A text-based means text, as here you can see, is the original programming language, which have powerful programming capability, which facilitate LaTeX for different formatting in your document. LaTeX includes features designed for the production of medium to large technical and scientific documentations. Why we are saying medium to large? Because for small documents, LaTeX will not be a good option. Because for here, even if you have to write small document, you have to write 2 or 3 more commands. So that's why for small documents, MS Word will be a good option. But for large documents, LaTeX will be a very good option. So LaTeX is a standard for communication and publication of scientific documents, and it can be used for almost any form of publishing. So in LaTeX document, mainly it will be a plain text file with some additional commands, which helps in formatting for our document. LaTeX is not a word processor. You know, in MS Word, as we write, MS Word is also a document preparation system. So in that, in MS Word, we write our content as well as we have to take care about the appearance of the document. But here in LaTeX, you have to write only the content. Only author should have to focus only on the content, right? Content of the document. Rest, the appearance will be taken care by the LaTeX only. So the quality of document improves. For installation, you have to start working, you have to install 2 softwares. One is MikTeX, another one is Text Editor. MikTeX basically provides packages for LaTeX, which helps in formatting process of the document. And next is Text Editor for LaTeX, where we edit our content of the document. So Text Editor can be Text Studio, Technic Center. All this can be easily downloaded from Google. These are open source software, so you can download and you can work with. So MikTeX you can download from miktex.org. Now, what are the advantages of LaTeX over MS Word? Because from many years we are used to of MS Word. So why to go for LaTeX? First, we must know what are the advantages of this. So in MS Word, whenever you have to write some document, you have to take care about the content as well as the formatting. But here, LaTeX will take care about all the formatting process. You don't have to do manually adjustment for font, text size, text flow, for readability, or for any appearance. You don't have to take any pain, any effort you don't have to give. So document structure is visible to the users and easily copied to any other document. Once we have written some written commands for the formatting in one document, the same command can be used for other documents. It can be easily copied. Next very important thing is LaTeX do the formatting for us, for our document. Also, the formatting is very consistent throughout the document. Without giving any effort, the formatting will be consistent. The LaTeX was first built for mathematical formulae. So mathematical formulae can be easily typeset in LaTeX. Also, indexes, footnotes, citation, and references, all these things can be easily generated. Then, as I told, that there are different text editors for LaTeX. That is Technic Center or Text Studio. So once we write the source code for one text editor, the same source code can be will work for different editors also. So this gives us flexibility. So here you can say that in LaTeX, you are forced to instruct your document correctly. You are not giving any extra effort, still your document will look good. You are just focusing on your document content, still your document will look good without giving any extra effort. So you are forced to instruct your document correctly. Then comes common elements of writing. Whenever you are going to write some document, what can be the common elements? The common elements will be text, figures, tables. Then you may use bullets. You may have references. Then in text, you have to take care about the colors, font sizes, special characters, paragraphs, sections, table of contents. So all these things we can have in LaTeX also. We will see one by one. So now let us start with the LaTeX program. So the first step, whenever you are going to write any document, what will be the first thing? First thing, you must know what is the document class. Means what actually you are going to write. The document, is it article or is it report or is it thesis or it may be an application. So according to the document class, you will use different formattings. So here also in LaTeX, first you have to define document class for your document. Then accordingly LaTeX will do the formatting. So here, to define the document class, the command is first in LaTeX, always whenever you are going to write any command, you have to use backslash. Here you can see the backslash. Then after backslash, you have to write document class. Then in curly braces, you have to define the classes. That class can be article, can be report, can be book, can be memoir, can be slides. In document class, there can be some additional options. Like you can define the font size, that is here, as you can see, the 10 point, 11 point or 12 point. By default, it's 12 point. Then you can write it's a final draft or it's a final document or it's a draft. You can define the paper size, say A4 size or letter size, or you can write here two-sided paper document or it's a one-sided. It can be one column or two column. In this way, there may be different options. Here you can see all the optional commands will be in square bracket. And the mandatory commands will be in curly braces. Here, this square bracket commands are optional. You can leave that. Also, you can combine more than one command in with commas in the square bracket itself. Then, after defining the document class for any document, you have to write another command \begin. Then in curly braces document. For any LaTeX document, this will be the common things. So here, this is the absolute minimal LaTeX document for LaTeX. The first thing, we have defined the document class, then begin, then /begin document. After that, you have to write the content of your document. Here in box, I have written the content of the document, which is hello there. In your document, only this will be printed. So if you want to print this hello there, you have to write this 4 commands, then only this will print. That's why I told that for small documents, LaTeX is not a good option. If you have to print just these 2 words, no need to write this 4 commands. You can write easily these 2 words. But if the document is large and you have to take care about the appearance, about the formatting, in that case, LaTeX will be a better option. Content of the document, you have to write \end, then in curly braces, document. So whenever you are beginning something, you have to end that. So here, whenever we use \begin and \end, so this is called an environment in LaTeX. So begin, then curly braces document means it's a document environment. So whatever you have to print in your document, that you have to write in document environment only. So after that, if you write anything below this end document, this will not be printed in your document. This will be ignored by the LaTeX. Okay. Here there may be some additional things. First thing, you have to define the document class for any LaTeX document. Then if you are using different colors in your document, in that case you have to use different packages. Like here, there are different. If you are using color, you have to use \use package curly braces color. As I told, this MikTeX provides packages for the LaTeX. So here MikTeX will provide these packages for different applications. Also, if you are using figures in your documents, so you have to use package graphics. So these things, according to your application, you can use different packages. All these things will come before begin document, and that is called preamble. Then after begin document, you will write the content of the document, and then in document. So this hello there is actually text of your document. This rest thing is used only for the formatting. Then comes sentences and paragraphs. Always, whenever you write some documents, there will be sentence, there will be paragraphs. So in that case, whenever you are writing documents in Word document, you have to take care about the spacing, you have to take care about the indentation, you have to take care about the paragraphs. So, but in LaTeX, what you have to write here, just here in blue colors, you can see this is the content what the author have written in document environment. Okay, so here you can notice this unnecessary space between two words, this interword space which is unnecessary, which is actually not required, but author have written is randomly without taking care about these spaces. Here also you can see here the vertical spaces between two para, okay, which is actually unnecessary, but author is not taking care about it. Author is only writing the content. But when we run the program, LaTeX program, LaTeX will print this, which is given here in boxes. Here you can see LaTeX has already omitted this unnecessary space between two words and between two para. So this is the beauty of LaTeX, where we don't have to take care about this small formattings. Also, when we are giving the vertical spaces between two para, LaTeX will understand that it can be two different para. So it will give the indentation before first word. You can see here, and also you can notice that the indentation for both the para is exactly equal. We have not given any extra effort for this, but it will give this indentation by itself. Okay. Next, sometimes it's the need of your document. You want this vertical spacing in your document between two para. So in that case, you have to use this double backslash. Double backslash is actually command for new line. So double backslash, then in square bracket you will give the spacing like the measurement. This is here given 0.2 centimeter. So according to your application, you can give here the spacing, and here you can see the space. Again, here another command is here in LaTeX document. In the document environment, here I have written backslash, then footnote, then in curly braces talking about footnotes. So whenever we are using backslash, means it's a command. It will not be printed in your document. Here you can see this is the printed document from LaTeX. So here this backslash footnote is not written, but here one you can see here one appears. So whenever you are using this footnote command first time for your document, then one will appear here, and the footnote, the curly braces, you have written the talking about footnote. This is the footnote comment actually. So this will be written here in the footnote. If you use this footnote command for the second time, automatically here 2 will appear. You don't have to give any extra effort for this. Again, in the document environment, whenever you will use this percentage sign, so it will consider this as a comment. This is not a command. This is not the content of the document, but this will be a comment. So LaTeX will not print this. You can see here, this is a comment. This is not printed in the LaTeX document. Now, as I told, whenever you will write a command in LaTeX document, you have to use backslash. But sometimes in our document, we need to print that backslash symbol. So in that case, there are some 10 special characters for which, if we want to use these characters to print these characters in our document, you have to use these symbols like this. If you have to print hash, you have to write backslash, then hash, backslash, then dollar. In this way you will write, then only these symbols will be printed in your document. And about the backslash, you have to write backslash, then text backslash, then it will print backslash. Otherwise, whenever you will use backslash, it will not print this, and it will consider the next word as a command. After that, for any document, you may have to build a title page for your document. So in that case, if you have to build a title page like this in a Word document, you have to give this spacing manually. You have to take care about this size, font size manually. Then this size and this size, all these things you have to take care manually. You have to give, you have to set the size and spacing manually in Word document. But here in LaTeX, you have to just give command /\title. Then in curly braces you have to write the title of the document. Okay. After that, /author. In curly braces you will write the author names. Again, /date, you will write the date. After that, you have to write /make title. Then LaTeX will build this title page for you. You have to just write the title for your document, author name and the date. Rest things, spacing and size, it will automatically adjust. Automatically you will adjust, it will adjust that title should be bigger than the author name, and rest accordingly it will adjust. So here you can see you don't have to give any extra effort, you have to just write. Rest thing LaTeX will take care. In title you can see here, like if you want A should be in caps or C should be in caps, so you have to write as it is in curly braces, it will print as it is. Only it will take care about the font size. Style you have to take care. Then comes sections. So for section, the command is /section. Then in curly braces, we have to write the section title. Also, there are some other commands. You can have subsections, you can have subsections. Then you can have paragraphs, subparagraphs, chapters. So this is the example. Here, /section then in curly braces, this is the section title. Then the content of the section is written here. After that, again /subsection, then in curly braces title of the subsection, and here you can see similar way. When we run the program, LaTeX will print like this. Here you can see the size of the section title is bigger than the subsection title, and this is bigger than the content of the section. Content of the section. So here you are not defining anywhere what should be the title, what should be the size of the section title, what should be the title for the subsection title, and what should be the title, what should be the size for the content, and what should be the spacing between these two. All these things are taken care by the LaTeX only. We are not giving any extra effort. You are just writing the content, and LaTeX is printing according to the requirement. Again, sometimes if you want the section title, if for example sometimes section title is very bigger and you don't want to print that bigger title in your table of content, so in that case we can use some additional commands. So first thing, to make table of content, the command is /table of content. If you write /table of content and you will print that, you will run the program, you will see here the content as shown here. But in Word, you have to give some extra effort to make the table of content, and every time you have to update. In Word also you have the commands for table of content, but every time you have to update that. Here it will be automatically updated. Again here, like as I told, here the section title is very bigger, Earth's most intelligent animals, but you want to print only Earth intelligence in the table of content. So in that case, Earth intelligence will be written in square bracket, and then the actual section title will be in curly braces. So here you can see the Earth's most intelligent animals, which is the actual section title, will be printed here in the document, and the Earth intelligence will be printed in the content. So always, whenever you are writing the square bracket, that is optional, which you can use and you cannot use. Same thing is here also in subsection and in different sections. After that, for the margin of the paper, here you have to use package text. Then you have to first define the size of the paper. Then you can define the top margin, left margin, and you have to give the kind of command in curly braces geometry. Another can be if you want equal margin for all four sizes. So here you have to define the paper size and then centering. Then all the margins will be same for all four sizes. Then sometimes we want spacing between two words. So in that case here the command is \h space, means it is horizontal space. Then you can define the space, what in how much space you want. Like this can be 5 mm, this can be 10 mm. So accordingly, here you can see space between the two words. Also for vertical spaces, here if you, the command is \v space, then 1 centimeter. So here 1 centimeter vertical space you can notice here. Sometimes if you will write here, sometimes if you will use this command \h space and then the amount of the spacing in the beginning of the sentence, it will not give the space, as here you can see here. But if you will use the star mark with this h space, then you will show, then it will show this space at the beginning also. Same thing here, another command is \h fill. So here you don't have to give the measurement how much space you want to give, it will adjust automatically. Another is dot fill, it will fill by the dotted lines, dot, and here h rule, so that it will be underlined space between the two words. Again here also, if you will use the star mark, so it will use, then it will be print, and then the space will be printed before sentences also. After that, the formatting, that there may be different text styles. So for that, different commands are there. For italic, you have to use \text it. Then in curly braces, the word which you want to print in italic. Okay, only this, the word which is written in curly braces, which will be printed in italic style. Here you can see. Also the command next is \underline. Then in curly braces, underlined text. So here underlined will be underlined only here. So whatever text you want in this style, you have to write that content in the curly braces, then it will be print as it is. After that, as I told you, if you want different colors in your document, so you have to use different packages. You can use package color, or you can use X color. So command is here, you have to here you can write this text in curly braces \color, then in curly braces blue is in blue, then again curly braces close. You can see the format, the syntax here. Okay, so after \blue, the word is written, the sentence is written is in blue, so that is written in blue color. You can see here, which will be printed in blue color is in blue. Okay, different formatting is here. You can write \text color, then you have to define the color. After that, in curly braces separately, you will write the words which we want in different color. So here you can see in different colors. By default, it will take the black color, otherwise you can define. Then comes the size of the font. One thing we have already discussed, you can define the document class. It can be 10 point, 11 point, 12 point. In other way, you can also define the text sizes. That can be \teeny if you want the text with text is very small. Then \script size, footnote size, small. All are comparable. You can use, and then you can see whatever size you want. Accordingly, you can use. Sometimes you can define your own size, your own font size also. The command is \def, means define, then \myteeny or my whatever name you want to give. Then in curly braces, \font size, you can define your font size. Then \select font, curly braces close. So you can define your own size. If using this command you are not getting the actual size which you want, so in that case you can define here also. Then next comes itemize or bullets. In many times in our documents, you need to use these bullets or numbers in your documents. So in that case, here this is the complete document, complete LaTeX document. So first thing you have to define the document class. Here I have already defined the paper size. Then begin document, means the document environment has been already started. After that, for itemize, you have to start again different environment, that is itemize. So \begin itemize you have to write. Then you have to define different itemize styles. Here we have used bullets, C dots, diamond shape, or asterisk shape. So here the command is backslash renew command, then in curly braces, backslash level item 1. Level item 1 here, this is the first level. So for that we have defined bullets. Next, renew command, level item 2. In Roman it is written 2. So the bullet style is C dot. So it will be a circular dot. Okay, for the second level. Then for the third level, it is diamond shape. So here third level means inside that. So this is the third level. This is diamond shape. Then again, this is first level. That's why it's the bullet. Again here, what should be the, this is, here we have defined the style for the bullets, for the items. But what will be the content of the levels? So here it is written first item slash item, first level, first item. This is just the examples. You can here it can be any content, whatever you want to write. Then again, if since it's a second level, means it is again itemized within that itemized. So this is nested itemized, nested, you can say nested environment. So here first we have used begin itemized. So this will print first item. First item we have used first begin itemized. Then within that first item, second is begin itemized. So this will be the item. This will be the second level. So in second level we have written two sentences. So for that circular dot is used. Again within that second level, third level is used. That way again you have to start begin itemized. Then the third level you can write. In third level also you have two contents, two sentences. So here this is written two sentences. After that we have not used fourth level. Still here we have defined the bullet style for the fourth level also, asterisk style, but we are not using here. So for the third level, which is innermost, so for that we have started this begin itemized. So you have to end that begin itemized. Then for the second one we have started begin itemized. We have to end that begin itemized. Then again here we have written for the first level we have written another item. So here another item is written, then end itemized. So here you can see these two are for one environment, one itemized environment. These two are for second itemized environment, and this end is for the first itemized environment. Okay. So all three environments are closed now. Then you have to use this end document. So whenever you are beginning any environment, you have to end that. Okay. Another thing, sometimes you can use ordered listing. So here you have to define same package, same thing. In the same way, you have to use different package here. The different package is enumerate and color. Color you have used because here we want the bullets in different color. If you don't want to use different color, so no need to mention this color package. Then same way you have to start the document environment. Then another environment will be enumerate. This is just the packages used for different applications. So enumerate, then the command is in square bracket. Again the curly braces backslash color. Color is red. You can define here color. Then in backslash BF is for bold faces. Because these bullets are bold faces, the command is BF. Then what bullet style you want, what number, it is A dot. If you write here 1 dot, so it will automatically print 1, 2, 3. Here we have started A dot, so it is A, B, C. Okay. So backslash BF is for bold faces, backslash color is for color, and here we have defined the red color, and then A dot is for the ordered style. Then what will be the content of the item? So first item, then the second item, and the third item. Here you can see battery.
ये सेम लगता है सेम लगता है
Okay. So here you can see at the time of writing the program, I have given this space. Here, the first item is backslash item, then the first item, backslash item. These are aligned with, these two are aligned, but the third one is not aligned. But still, whenever you will run the program, LaTeX will print with the same alignment, because this here same item, same level item, so this should be aligned. If this is a second level item, then this should be inside this first level. Again, since we have started one environment, we have to end that and enumerate, then end document, LaTeX will print. So this is the output of this program. This is the complete program to just print these 3 bullets.
problem ଅଛି data is connected.
Next, as I have already told that we can use nested itemized. So here also this is another example. First, just in begin document you have to write begin itemized, then the first item. This is the second item for the first level. Then within that begin enumerate, means this is combination of bullets and the ordered listing. So first here we have defined the triangular shape here, as you see in the output here. So first level and the third level, which is triangular bullet, and then in begin enumerate. Whenever we will use the enumerate, means it's a ordered listing. So here first item number 1, item number 2, item number 3. So here you can see the output is 1, 2, 3 bullets are. Then again within that begin itemize, first item dollar shape, then backslash spread shoot dollar shape, then square bracket close. So here you can see this is another shape, spread shoot, then heart shape, then diamond shoot, then club. So for different shapes you can use this shapes also you can use for bullets in your documents. So again this is nested. So this and this we have started the begin. We have started the itemized environment. That should be ended. Again end enumerate, because this itemized environment was inside that enumerate, inside that third point number 3. So that's why first this should be closed, then this should be ended, enumerate should be ended. After that the last item, then end itemized. So this is also the example of just nested bullets. Next comes figures. Whenever you have to use figures, insert figures in your document. So in LaTeX, in the same way, first thing you have to define the document class. Here, as you can see here, you have defined document class. This is article and the font size. After that, as I told, whenever you have to insert figures, you have to use package graphics. So here use package graphics. Then document environment will be started. You have to start another environment figure. So backslash begin figure, end figure. Within that you have to write this commands. First is backslash centering. This is used for if you want the figure should be centered. So then you will use this. Otherwise it will be left aligned or it can be right aligned. Then backslash include graphics. If you have some figures in your system, so you want to include that graphic in your document. So that's why the command is include graphics. After that, what should be the dimensions of the figure? Here you can define what should be the width, what should be the height. Then that should be written in square bracket. Already, as I told, whenever you are writing square bracket, these are the optional. You can leave this blank also. Means if you will not define this the dimensions, it will take something default sizes. And then next is in curly braces, you have to define the name of the document, name of the figure, which name, the same name with you have saved your file, your figure, the same name you have to write here. After that, backslash caption, in curly braces you can write some caption. If you will not give caption name, like as I written here, this is blank. So here you can see this is written figure 1 column, but there is no caption. So this is blank. If you want to write something, you can write here in curly braces. After that, backslash level, curly braces, figure colon figure 1, figure colon garden 1. Garden 1 is actually the name of your figure, name of the figure which you have saved this file in your system. So this level is actually used when you want to refer this figure in your text. Obviously, whenever you are using some figures in your document, you will refer that like in figure 1 you are showing this, in figure 2 you are showing this. So in that case, in Word, if you are writing, you have to write manually that in figure 1 you want to show this. But in LaTeX, you will use figure.garden1 or maybe some other thing, some other name, whatever you want to write here. So automatically it will count, it will detect that this is figure 1 or this is figure 2. You have to write this level and it will automatically detect the figure 1 or 2, whatever it is. Okay. Then another style can be, you can start figure environment, then same thing, centering, include graphics. You can define only the width, and the next the caption level. Same thing, since as you can see here I have defined width and height, so figure dimension is something else. Here I have defined only width, so figure dimension is something different. You can see here other thing, both are same. But here if you want, if your figure like whenever you are start working with LaTeX, you must have one folder for LaTeX. So this figure should be saved in that LaTeX folder only. Then only you can use this command. Okay. If the figure is in some different folder other than that LaTeX folder, then you have to define the path. Where is the figure? So in that case, with use package, you have to use another command, /graphics path. In the preamble, you have to define the path for your file, for your figure. So command is double curly braces. Then you have to define the path, the same wherever you have saved your file. Here you can define here. After that, same thing. Rest things are same. The figure environment is exactly same. Include graphics, centering, caption. Here I have given the caption beauty. So here you can see figure 1: beauty. After that, end figure and end document. Okay. So if your figure is within the LaTeX folder, you don't have to give this path. Otherwise, you have to define the path. Next comes tables. In tables also, just like in figures, here also you have to start another environment, that is table. So here begin table, then first command is /caption. So there, for any table you must have to give some captions. So here /caption performance. This is in this example, this is written performance. After that, centering. These commands are optional actually. You can use here different alignments also. After that, /begin tabular. Then in curly braces, here you can see the command is C, then this vertical line C, vertical line C. This is used for centering. Like the items, the content of the different rows and different columns should be centered. So here you will write C. If you want this right alignment, so you can write here right. If you want left alignment, then you have to write here L. Okay. Then comes the items. What are the content of the table? So here, for different rows, you have to use double /, and for the different columns you have to use the ampersand sign. So here, the first item is CD, video and table. CD, video and total. These are the items for the first column. So here you can see. And the second is cost, third one is quantity. So same way you can see here, different columns are separated by ampersand, different rows are separated by double /. Then you have to use this end tabular. Here also you have started one environment, you have to end that environment. Then /level tab : H results. Here it is just the name of the table, whatever you want to refer in the text. If you don't want to refer this, you can leave this command. You can omit this command. After that, in table, in document. So to print this table, you have to write in the same way, different environment, the tabular environment and the table environment. Okay. Now, as I written here, C, then this vertical line, C, this vertical line. That's why you are seeing this vertical line. If you write only C, then this vertical lines will disappear. Next is equations. In any document, you may have some equations. So for that, you can have different environments. Within document environment, there may be different formattings according to your application. Like in this example, you can see one style is you can use within the text, within text, you can use double dollar sign, then your equation, then double dollar sign with that will be closed, and after that your content of the document. So this will print like this. You can see here, if you use double dollar sign, so the equation will be separated from the text. But here, if you will see here in the last section, with the text we have used the command backslash, then in small bracket the equations are written. So this will be written with the text only. This equation is not separated from the text. So for different appearance, there may be different commands. Again here, there may be some different the different style also. Like here, you can use different environment, begin display math, and then you can write the equation, then end math. Obviously, you are beginning something, you have to end. Again, next can be this begin math, and then again end math. You can see whenever you are using different style, you will have the different appearance. So for display math, you can see this is separated from the text. Whenever you are using only math, this is within the text only. Okay. Another thing, you may have like equation numbers. So for numbered equations, you have to use begin align. If you use begin align and in align, so in that case here, since here we are talking about the alignments, so here y is equal to, so this will be treated as a table. So in table, as I told, different columns will be separated by ampersand and different rows will be separated by the double backslash. So here for columns, here y, then ampersand, then equal sign. After that, you will write the equation, whatever equation you want to write. The double backslash means different row will be started. Then ampersand means another column. Since we are using alignment, so here you will see this alignment. Okay, means these two equations are aligned. Means both are actually y. Y is equal to this. Y is equal to this. Okay. Then after this equation, we have written backslash no tag. So whenever you are using align environment, so for every equation you will have one equation number. But since in the second equation we don't want the equation number, that's why we have written no tag. Backslash no tag means it will not be tagged as the equation number. Okay. Then in align and in documents. Okay. Again, this is also same thing. If you want to equation numbers and you want to refer those equations in your text, like in equation number 1 from equation number 1. So in that case, you have to use, like here, begin equation. This is another environment, begin equation, and then equation, whatever equation you want to write, then backslash level in curly braces my tag. Means whatever equation number will be here, like if it's equation number 1, so whenever you will refer this, like in this sentence, here you can see backslash EQREF means equation reference, then in curly braces my tag. You can write here something else also. So my tag. So if you are writing my tag, so if the equation number for this equation is 1, it will appear here 1. If equation number is 2, it will appear here 2. As you can see here, for this equation number is 1. So in text, it is written only 1. Okay. So you are not giving a first for this. What is the equation number? What was the equation number for that equation? You can just write that my tag. It will automatically detect. Okay. Till now, any doubt from any centers? Any doubt from any centers, or I am going very fast? आवाज आ रही सर? Any doubts or should I move forward? Next is citation and references, which is very important. Like this is an example. First thing, you have to define the document class. Then the package you can omit. If you are using this using figures, then only you will use this package. After that, whenever you want to refer something, you want some papers, you want to refer some papers in your document. So in that case, the command is \cite, CITE, \cite. Then in curly braces, you have to write some code. From where this code is coming, that will show you. Okay. Same way here. So in this document, we have cited 3 documents. And after that, you have to use \bibliography style. What should be the style of the reference whenever you will run the program? So here the style is abbreviation. Then \bibliography, there will be a BibTeX file in LaTeX. So what is the name of that BibTeX file? That is written here. So when you will run this, then you will see this output. We have cited 3 documents. So automatically it has already detected 1, 2, and 3, and references are already built here. Now, the question is from where we are getting this course. So for that, so here this is the text studio. As I told, the text editor for the LaTeX. So here the screen for the text studio. Here I have written this example. Different examples also. ये दिक्कत होती है बड़ा अच्छा यहाँ से न्यू जूम नहीं होती ऊपर चलेगी है ना नहीं तो जूम होगी तो ऊपर चलेगी हाँ पर ये जूम हो रही है ना ये कोडिंग जूम नहीं होती बट स्टिल रीडेबल है सर दिख रही है Okay, so this is the text studio editor window. So here, as I given already, as I shown you this example already. Here, as I told, whenever you are writing, like this is one example document. Okay, first time you will write this. For example, you have written these examples, this program, this LaTeX document. You have to click this build and view. You will run this. and here this is the output. Okay, now here the output will be in PDF format. Okay, so this is the complete document. You can see the outside also here. This is the external viewer. If you click here, so from here you can see we have just used table of content, one command here, / table of content. Okay, and of the table of content you can see here. This is very nicely, the font size, spacing, all these things are automatically generated. We are not taking our anything else. Here you can see one difference. Another, like for example, these are the chapters 1, 2, 3, 4 up to 7. But the last one, the number is not appearing, but still this is showing in the table of content. So for that, obviously references are not numbered, but still you want to see in that in your document. So for that you have to write one command as we have written. You can use section then asterisk sign. If you will use asterisk sign before the title of the section, then it will not show the number. Okay, and still it will be included in the content of the table. So that's why here the number is not showing, but it is showing the table of content. Rest already just we have defined the sections. This is section, this is subsection. Size is automatically LaTeX is deciding. Okay, the respective size, this should be bigger, this should be smaller, this should be smaller. All these things are taken care by the LaTeX only. Here you can see all the spacing. Then comes figures. Like in figure 1, what we have written here. Yes, block diagram, this one. So here, figure. Here, whenever you will write / then figure, after that you will write this square bracket H. So if you write square bracket H, so this means here you want to print the figures here only. Otherwise, sometimes when in Word, whenever we insert some figures, so sometimes the text, once we have written the document, after that you want to add some text, sometimes figure comes down in the next page and then the unnecessary space created. So in that case, LaTeX what it does that it automatically adjusts the text, maybe above the figure, maybe below the figure, but the space, unnecessary space will not be appear. So that's why, so it automatically adjusts. Sometimes you want your figure should be here only. You don't want to move that figure up above or below. So in that case, you can use this square bracket H. H means here. If you will not use this, then LaTeX will adjust automatically figure in above the page or in below page. Okay. Then here the include graphics, captions, and the level, as already here we are seeing. This is the complete document. The text editor, only few commands are used. After that, document is looking completely perfect. We have used just few commands here. The document class in the package. In package, we are just defining the margin. What are the paper size? What are the margins? What are the bottom margin, top margin? Okay. Then here the paragraph indentation. These are the optionals. What is the paragraph indentation? If you want to define yourself, then here some measurement is given 5 EX. Otherwise, it will take automatically some standard length. Then here this is used renew command, baseline stretch 1.5. And what should the line spacing? Standard is 1.5. We use normally line spacing. So here we can define. Otherwise, you cannot. So just for better look, we have used two to three more commands. Otherwise here you can see only the content is written. Only the content of the documents are written. These are all the contents of the document. No more commands. Still, document is looking perfect. Okay. Here also, this was the example what we have shown here. When we run, you can see. Panduri? जा रही है आवाज? जा रही है? Okay, so this was the example what we are talking about, the references and citations. Okay, same thing, same document, same LaTeX document. Here we have run, and this is the output. The question is, from where we will get this codes, Agrawal, this and this HN. So for that, you have to build one BibTeX file. As I told here, one BibTeX file. Here we have used Synopsys. So from where we will take that? First thing, we can export BibTeX file from different sources. One example is Mendeley. Like if you have the Mendeley software, or there are different softwares also in MS Word, like there are Jotero and Aurora we can use. And one very user friendly is Mendeley. That's why we are using that. So in Mendeley, like for example, folder Synopsys. So you want to export these papers in different BibTeX file. For example, we want to export these 3 papers in BibTeX file. So we have selected these 3 with the control key. Then go to file. Then here export. automatically here the save as type is coming BibTeX. So here you can give the name. For example, my collection 1 I have given. It is automatically saved in, you can see, LaTeX folder. If it is not, if it is not the default path, you will select this same path. You have to save this BibTeX file in the LaTeX folder only. Okay, so my collection 1, save. Go to LaTeX folder. Then you can see here my collection 1, a BibTeX document is already created. Okay, so if we will open this my collection 1 from here in the Text Studio, you can see from the open, you will go to that LaTeX folder. Then my collection 1, open. Then this BibTeX file will be opened. You can see this, we have selected 3 papers. So 3 citations are coming, 1, 2, and the third one is here. Okay. So these are already, BibTeX has already exported information of the paper. Here you can see the author name, then this is the path of the file, then what is the title. Okay, here also sometimes it already extracted the abstract of the paper, then author, DOI of the paper, then ISBN, ISSN. Whatever the informations are already given in Mendeley, it is already exported in the BibTeX file also. So all these are informations of the papers, or the 3 papers what we have selected. So what you have to do is just create this BibTeX file. Whatever paper you want to cite in your paper, in your document, you have to build this BibTeX file. Then these are the codes, like here Agrawal 2014. So the first code, this is already given in different color. You can easily distinguish this Agrawal 2014, or here the last one is AHN 2016. Okay, so this code you have to write in your LaTeX document. What we have, /cite. After that, in curly braces, you have to write this code, Agrawal 2014 AHN 2016. So whenever you will write this codes here, you will cite this codes here. Then you have to write here the name of the file which you have saved in your here BibTeX file. Okay, so here /bibliography synopsis I have written here. Here you will write my collection 1. Okay, just name here 1. Synopsis is also a BibTeX file. So I have used here synopsis, that's why the name is synopsis. If you are using this file, this BibTeX file, you will change the name here. Okay, here this is the BibTeX, the bibliography style abbreviation. This can be IEEE, there are different styles, so you can use this style, and accordingly you will see the output. Okay, here this is used for /add content line, then in curly braces TOC, then curly braces section, curly braces unknown. You can see here one section is India in this document, another is subsection is origin here, then another section is unknown, asterisk sign is given. That's why here the section number is not showing. Okay, but still, as I told, it will be included in the table of content. But if you don't want to include in table of content, then you will use this TOC, add content line TOC unknown, then it will not be showing table of content. Okay, after that, so this is all about the references and citations. So whatever, like here in synopsis, since we have cited only 3 papers here, so you are seeing here 3 references. Okay, sometimes we have used these 3 papers, you have cited 3 papers. After that, you just notice that this second one is not relevant for your document, so you want to delete this. So you will delete this paper, this code from here, this command /cite and this code. Then here this will appear. This will disappear, like 1 and 2 will appear here, and this 2 will be deleted. Still here you will see the three references. References will be still 3. So for that, what you have to do, why this 3 is coming, what you have to do for the correct references. Here you can see once we write one LaTeX document, then at least first time you have to run this document. Once we run, then you can see here there are different documents are coming with the same name text. I have written only one TEST. We have written only one test LaTeX document, but there are different files with the text, the same name, but the extension is different. You can see this is AUX file, this is BBL file, this is performance something, this is DVI file text document, and this is actually your PDF file, which is your output, and then WinZip file and this LaTeX document. This is your LaTeX document, which is actually which will be open in your editor. But these are the supporting documents. So for the references, as I told, if once you have cited 3 papers, and after that you want to remove one reference from your result, from your document, so in that case, just first close this output, close this PDF file. After that, delete all these supporting documents. Okay, apart from this LaTeX document, you have to just keep this LaTeX document. Here you can see here this is written type LaTeX document. Okay, all these auxiliary files, the supporting documents with the same name, you have to delete. Okay, then after that, delete one citation which you want to remove. Then again run. Then you will run, and again the supporting documents will be created, but these supporting documents will be updated documents, and then here you will see the. Otherwise, what happens? 3 papers. So already auxiliary files, the supporting files are created, and they have created 3 references. So in that case, whenever, even if you have deleted this one reference, you are seeing the three references. So that's why you have to delete all these supporting documents. Then only you will see the updated references. Okay. So all these supporting documents. For example, here, as I told that this is the PDF document. You want to, if you will change anything here, you will see same changes here also. Okay. Sometimes you want to keep this one also, the some updated file also. Then in that case, you have to copy this PDF file and paste somewhere else in the document apart from this LaTeX folder. Then that will be and save the file with some other name. After that, you change in your LaTeX document in your code, and you will see the difference. And then you will have the both final outputs. Otherwise, if you will copy this and paste here only, then it will be replaced with the same document. Okay. So this was all about the LaTeX. There are different application, like you can have fractions, just same as the equations. There may be some fractions, so there are commands \fraction. Whenever you are using $sign, so this will be created. This will be treated as a equations. With the $sign, you have to end that. These things come what window was coming. Actually, whenever you will run the program for the first time, you are using some packages in your document. So it will ask you want to install that package in your LaTeX document. So here you will click on this install. It will install that, like for example, AMS math package will be installed, and then it will show the result. Otherwise, it will not show. If the package is not available in your document, in your LaTeX software, then it will not work. Very useful thing is for LaTeX, whenever you are going to write some papers, some research papers. So in that case, in most of the journals, they give the LaTeX source code for the formatting. So in that case, all the formattings have already given. Only thing you have to write the content. is given, you have to write your content, you have to copy your content there, and the papers will be completed. Otherwise, you know, whenever you are going to write some research papers, they give their own format for the paper, and to write the paper in the same format is very difficult thing. Always, whenever you change something, whenever you change very small things, still the whole formatting will change, and you have to work again for that in Word. Whenever if you are working in MS Word, but in LaTeX, if they have given the source code, you have to just write the content, automatically the paper will be created. You don't have to do anything else. So this is very helpful for paper writing. And for the troubleshooting part, different, as I told, this is very common. You can search whenever you have any query, you can write in Google, you will get the results. Other than that, they have website CTAN. You will search in Google and you will get the results. Whenever you have any query, you just write that word, the keywords, and it will show you the codes in detail. Okay, they give the commands. You may have some disadvantages also whenever you are working with LaTeX. Like sometimes, as I told, you are forced to structure your. Sometimes it is difficult to obtain the certain look for a document. Like if you want some specific look for a document, so it may be difficult because it will adjust automatically. You want something else, it will adjust automatically what is correct word. But sometimes you don't want that correct thing. So this can be disadvantage. Also, sometimes, like at least first time you have to run, then only you can see what is the appearance of your document. Otherwise you cannot see. Like in MS Word, you are writing and simultaneously you can see that what is the appearance of the document. But in LaTeX, first time at least you have to run. So first time for document will run only when your document, your LaTeX document is it don't have any error. So you have to take care about that. If LaTeX document if in the code, so it will not work, it will not run, so you cannot see how your document will appear. So in that case, this is also disadvantage of the LaTeX. But once you run, you can see. Okay, this is another example for table. As I told, here also as I told, for columns you have to use ampersand. For rows you have to use this double black backslash. If you want spacing between different rows, as in first example we have not defined this spacing, so all these rows were very close to each other. If you want separation according to your application, so you can define here. So here also in square bracket we are giving the spaces, means this is optional. So here we have given the spaces, so you can see here. Also here, as I told, this vertical lines means here vertical lines are coming. Here we have written this after the caption, double horizontal line we have written. We have given backslash h line. Backslash h line means this is horizontal line. So two times we have written this command h line, means two horizontal lines are coming. Okay, after the caption, then table has been started. Okay, then the table, the first the headings are audio name and the sum of the extracted bits. Here you can see same thing. Again, if we have written this backslash h line means horizontal line, and after that backslash c line 1 to 7 means what should be the length of this horizontal line we have defined here. So this is 1 to 7, column number 1 to 7. Here we have not defined, so this here you can see these lines are up to this only. This will be randomly selected. Okay, but if you will define this 1 to 7, so this will be up to 7th column. Okay, here also we have defined the space between the rows, like after that, after this headings, what will be the length distances. Okay. Fraction already I have told. There are different commands. We have to use this $sign, then backslash fract, then fraction. This is the numerator, this is with the denominator. Okay, sorry, this is numerator and this is with denominator. Okay, this is a different style. Defract. This is again the square backslash SQRT27 means this is the symbol. If you want to print this square root sign, so the symbol is, the command is SQRT. Okay. Any doubts? Any doubts from any centers?
Any of the centers, if have any doubt, they can switch on their mic.
Yeah. Video.
Okay, thank you, ma'am. Now we can call it a day, and we will reassemble tomorrow at 9:30 sharp. Thank you. Yeah.
बिल्कुल सर, लिखना हो तो पहले, लेकिन वर्ड में